looks like it says I'm live, but I have no watching now or viewers or anything yet.
So it's a new link, so it may take a second to get the kids over there once you're in there. But yes, it says live. I've not seen a webcam like a live screen on my side, so I'm not sure. Oh, there you are.
I think it'll be the same thing as last time. I'll just need to know. I might have the issue with the two microphones. Remember how last time I had the issue?
Yeah, I will listen and go from there.
I'm going to go right to share screen just so when people do come in, I'm already...
Right, yep, and then I would just start going and then with everybody there, so...
Is even when I tried that /present in the basement, that wasn't working either. So maybe it is a laptop thing. We'll see. Which, it's just one of those things. What are the chances that the entire thing crashed right in the middle?
Yeah,
maybe.
But I think you're good. So I'm gonna let you go, and then
okay.
We'll just text from here on out.
All right, thank you. And just start talking. Okay.
Yeah, just go with it.
Thank you. Bye.
Yeah, bye.
All right, guys. We are going to kind of pick up where we left off, and I'm going to thank you for your patience. As always, I'm going to jump right in and kind of speed through the first stuff just so we can kind of get caught up and back on track. I am so sorry about that. We love technology. It works so good when it's working, right? But let's jump right in. I already kind of did the introductions, and you already all know this, and you guys are amazing. So we know that, we're recorded. We'll keep everything neat and clean. And if you don't want your name to appear, then change it. You might already have seen this, the video here. I'm going to kind of just play this. It's just a real short video. This is our pep talk from Amanda, who is
what up, AP students? Amanda here from Fiveable. We are literally giving away $100 to pay for your AP exams to like 50 different students. How do you win? Easy. You just got to post about the AP experience on social media, on TikTok, Instagram, or Twitter. Use the hashtags YesWeCram and with Fiveable, and tag at Think Fiveable. So one person will win every single day, and this is how you can win. It is going to be a group of students who actually judge the winner. They will pick the winners, and this is how they're going to choose. It has to capture the AP experience. Do they look at that post and think like, that's 100% what this feels like? Is it creative? Is it funny? Does it have a really awesome song in it, or really good use of some sort of meme? Anything. Do we see creativity and engagement? How many likes do you have? That literally is going to help you win. The more likes, the more likely you are to win. And then finally, does it incorporate Fiveable? Is it in the caption, what you're wearing, in something that you're doing? How have you incorporated Fiveable into it? So this is how you can win. A couple of quick notes. Make sure you follow Think Fiveable so that we can DM you if you've won. You can post as many times as you want. You can post today, tomorrow, every day, as many times during the day as you want, but you can only win once, so keep that in mind. And finally, some of our best social interns came from this contest last year. So if you're really awesome at social media and you're looking for an internship, show us what you've got, because we want to hire you. So I can't wait to see your posts. See you on the flip side. Good luck on your exams. Talk to you later.
All right.
What up, AP students? It's Amanda here from Fiveable.
So we are Fiveable, and you can find us on social media anywhere. So check us out, and if you, of course, can follow through on Discord, they will have help for you wherever you need it. All right, so jumping right in, we have 3 administrations of the end of course exam. The first one is administration 1, that is tomorrow, 8 a.m. local. And it is paper. It's going to be whatever your time zone is, it starts at 8 a.m. So make sure you're there by 7:40 a.m. It is in school. So we said about 80% of you, that is your choice. So keep that in mind. That's you. When we're done tonight, eat well, get a lot of sleep, and rock it in the morning. Administration 2 and 3, those I put in Eastern time zone. So just change that for yourself. You can always go to collegeboard.org to check what the correct time zone is. Those are the digital platforms. So we will talk about that because that's new this year in terms of, because of COVID. So Wednesday, 5:26 or Monday, 6/7. Now, for those of you who are taking administration 2 or 3, please remember, this is recorded for you. So you are here with us. You benefit from it. Come back and check out the recording. So if we talk about something today and it just doesn't stick in your head, right? You just need to review again, or you need a little confidence boost the day before or the time before. Make sure you get back on here. I already hit this in our polls at the beginning, but this Thursday at midnight, 11:59 p.m., that's the deadline for the create task. And friends, that is 30% of your test grade. So don't phone it in. Do it. Do a good job. Kick butt at it. And we will talk about that shortly as well, okay? So in those 1-hour CRAMs that we've been doing for each big idea, I asked you guys the last few times, what is it that you want? So I got out of you binary, data, numbers, conversions, hexadecimal. Guess what? Not on the test this year. So you will not have to do hex. This is awesome. Pseudocode. Yes, I get it. This is one that a lot of people think that they're not good at. They want a little extra help. We got it. Overview of big ideas. Got them. We're doing about 1 an hour with big idea 3 kind of flowing into a little bit of the hours around it. Code tracing practice questions. Yeah, I got some text-based. I got some block-based. We got it for you. Multi-step questions. Yes, I'm tracing in with that. I like this. Somebody said content and topic review. And what that means is not just the review questions and sample questions, but what big idea is, where does it fall in, that kind of thing, as well as test taking strategies. Some people don't realize that the AP exam is kind of gets harder as you go. Okay. So we want to kind of talk about that, test taking strategies. So how long do you have? You got 120 minutes for the multiple choice part of the test. How can we do well? Well, the easier ones come at the beginning of the test. So we want to realize that, right? And not divide evenly all the time that we'll have to take. All right, so here we are, hour number 1. I knew it was going to be a little shorter than 1 hour anyway. So we are still great on time. So our first hour, I'm going to talk about the paper and the digital testing app, the structure of the test, the reference sheet, and the create task. I am also then going to try and start some big idea 1, give you a little bit of break depending on the time. So I'm kind of keeping track of my time as well. So we can take little breaks. Just give yourself a little brain break. How's it going? Shoot some comments out to Rachel or myself and move on. We're going to kind of, if you look at this, we're kind of going to go through big ideas 1 and 2 in an hour. Big idea 3, I have an hour, but I also know that it may fall into or kind of creep over into hour 4 perfectly fine, because that is a third of the test. So we want to make sure that we give you a lot of the time for that. And then we'll finish up big idea 4. At that point, we'll give you another brain break, see how things are going, and then Miss Choi is going to take over for the last hour, right? Remember, she's in California, got a little time change stuff going on, And she actually had another conference. So we're kind of working the way that works best for you guys today. Okay, so again, after paper exam, those of you taking digital, you can tune out for a second on the paper exam readiness, or just pay attention to see what everybody else has to go through tomorrow. And then what we want to do is we'll talk about the digital as well. And if you then forget, you come back to it before your test. So if you're taking the paper exam, please make sure you know when and where you're going. So you are doing a bubble sheet response for this. Are you doing the bubble sheet tomorrow, or have you already done it? Right? So no stress. Do not stress if some people are like, oh yeah, I did this a week ago and you didn't. It is completely a school thing. You didn't miss anything. Okay? When, where, and what are you supposed to be? Meaning, especially because of COVID, what if your school is not open? Do you know where you're going in the morning? And make sure you're there, right? Get there. Remember your number 2 pencils. Get a good night's sleep tonight. Eat before that test. It's 2 hours, where some APs are 3, so it's a little shorter, but it's 2 hours right in the morning, right? So get yourself a little coffee, get yourself some healthy, good stuff to eat. It's a long time to sit still. Don't bring your hat, your phone, food, drinks, that kind of stuff. I'm going to throw the next slide up, which is really a thing I found on Twitter. Awesome. From the College Board, little what to bring, what not to bring tomorrow for the paper test. So most of it is what I already said, but it does clear up some little stuff about food and water, drinks, that kind of stuff. Bring your number 2 pencils. You guys really don't have the black or dark blue ink. You don't have free response questions on this, right? You don't need to bring a calculator tomorrow. If you are taking that 4th bullet, if you are taking the test where, if you are taking the test somewhere that is not your school building, which could be, right? Depends on COVID. So if it's not at your own school, please treat it as if you were taking an SAT or an ACT. Take a license or a school ID with you that has your picture on it, right? A mask, it just is part of our attire, right? So take it, whether you need it or not, you probably do, but take it with you anyway. Hand sanitizer, if you are somebody that wants to bring hand sanitizer with you, they will this year allow it in the testing room, but it has to be under your desk, right? So if you are somebody who want to walk in, sanitize your seat or your desk or wherever you're sitting to take it, and then you can store that under the desk. Water and snacks, please realize they're not allowed in the testing room. That's a College Board rule. But when you get to wherever you're taking the test, say it's in a gym or a cafeteria or a classroom or something, there will be an area outside of that where you can leave phones, hats, food, and drink. Please realize you can't have that during the test. You will get a break, and during that break, with proctored permission, you can have a drink or a snack. Okay. The only exception to that is if you have some kind of medical condition where you have a letter in hand with you from the College Board saying that you can have food or drink. That's the only exception. All right. So you also may, if you have extended time, if you have any other accommodation exceptions or adjustments, that then would be a letter. Again, if you're taking this with your own guidance counselor there and everything, they already know it, they have it on record. But if there might be a possibility that somebody doesn't know you, then take it with you. Things to not bring. Don't bring anything electronic. Don't take your phone, smartwatches, fitness trackers, any kind of stuff in there. Don't try and record the questions on the test. That's just silly. Don't bring any reference sheets, notes, anything with you. Don't bring scrap paper. If you're allowed to have anything, they will give it to you. Even just a regular watch. If it is a watch that beeps on every hour, don't bring it. They're not going to allow it in there. Anything that could distract or take away from anybody taking the test. No earplugs. And I know everybody owns lots of computer science t-shirts. Leave them home tomorrow. So don't wear anything having to do with the test. All right, now we're jumping into the minority, but those not taking the paper test tomorrow, please realize you have to download, and you have a teacher, right, who should kind of help you with this. Even if you're doing an independent study, your guidance counselor or your AP coordinator should help you with this. You need to download and install the testing app. That has to be installed on the computer that you're taking the test from. It can only be a laptop or a desktop. That does include school-managed Chromebooks, right? So if you are a one-to-one school, that's what that means. Their practice example questions are in there. I highly recommend them. Do that. And it's not just for extra practice, which is great too, but it's to make sure you see how things are going to work the day of the test. Okay, it's a different font. It's all showing up on the computer. Is it going to give you a headache? That kind of stuff. 1 to 3 days before each exam, complete the setup. Again, you have to take that or do this little setup check on the computer you're taking the test from. Then the day of the test, be there on your computer 30 minutes ahead. You need to kind of log in and give it time to like get the lockdown browser, all that kind of stuff. And the last thing, this is huge because it's different, because it's the first digital exam platform we have. If you skip a question, you cannot go back and do it later. Keep that in mind. I put a link there for you, collegeboard.org/AP2021. Says most of the stuff that I put in here, just in, I think it's 25 pages. So I kind of condensed it for us. Reference sheet is also there. So hopefully you have seen the reference sheet throughout the year. It's called student sections or student papers, and that's all great. So we will talk about that, but be familiar with it, right? The interface, the layout look a little different on the testing application than they do on the paper test. So be familiar with what it's going to look like. Don't the day of the test be like, oh no, I don't remember where everything is. Can't go back to the questions. You see, I'm going to say that a couple times just to remind us. You can, of course, do that in the paper, right? You can flip pages back and forth all day long. You cannot on the digital. And it's not that they're trying to penalize anybody. It is a testing security feature. So you get up, you go to the bathroom, you try and find out an answer, you come back and you go back to a question, right? They're trying to keep everything fair. So realize that. Exam directions. Exam directions will not be read by a proctor if you're taking the digital exam. They will be there in the application. And the reason I point that out to you is you can look at the exam directions. Again, I got some links in here for you. You can read the directions ahead of time. So if you're somebody that you either take a little time, read slow, get distracted, you can absolutely, they're the same directions on all of the practice test stuff. So you can read those exam directions ahead of time and make sure you know what's going on. I want to point that out to you because there isn't going to be a proctor where you click the button and somebody will read those directions to you. They're just in written form. Also, the exam timer starts when the directions appear. So although, teachers always say, we want you to read the directions, do so quickly. And if you're nervous, look at them ahead of time. Okay? So the full text of the exam section directions can be seen ahead of time. Check in 30 minutes ahead just to make sure everything is good, no computer issues. And then remember, again, my third time, right? If you skip a question, you can't go back to it later. All right, I had some students say, well, which one is the easier test? Or is there a benefit? Should I take the paper? Should I take the digital? And I do want to just point out to you, there is an exam page. I put the link here. You'll have access to it after this recording. You can go check it out yourself. All versions will cover the full scope of the course content. And I say that because it's not going to be that tomorrow's test will be easier because it's 2 weeks earlier or anything like that. So I do want to point that out. All three administrations are going to cover all the stuff that you learned. Okay, both paper and digital, the end of course exam will consist of the typical multiple choice stuff, right? So I wrote it here for you. You got 70 questions to do in 120 minutes. There's going to be A, B, C, and D, so 4 answer choices. That's going to count for 70% of your grade. The other 30%, like I mentioned, comes from our create task. So notice here, there is a little difference. It's still not a benefit or, somebody's test is going to be easier. But I do want to point this out to you. So the first 57 questions are choose the best answer, right? And then we'll have the 5 single select with the reading passage. That's what used to be, if you have anybody that you knew took it in the past, that was what we called the explore task. And then the last 8 questions will choose the best 2 answers. Okay, and you do get partial credit if you get one of them right and one of them wrong. So I did put here the note difference here. The only difference is 6 of the choose the 2 best answers instead of 8. That's the only difference. Okay. All right. So if you have any questions, feel free, type them into the chat, the Q&A for Rachel, and absolutely can unmute. Let me know if you have any kind of questions as well. All right, same thing. Going to the next sheet, I have 2 links here. Just want to kind of show you. They are a little repetitive or a little redundant, I would say, in the College Board, but you don't have to log in to see them. And if you haven't seen them yet, or you lost them and want to see them again, here they are. So one link is 25 pages, and it's called the Student Handout. This is twofold. It is the first few pages are how to do the create task and then the reference sheet. If you just want to see the reference sheet, that I sent you just a separate link for. So this is absolutely available during the end of course exam, and it is available on both paper and digital. So don't worry that one has it, one doesn't. It also, I like how it does go through the block-based and the text-based. If you see this, this is what it means. Okay. So if you haven't seen that, we absolutely can take some time to go through that. But I think that at this point, we did that in the earlier CRAMs. So you also would have access to those other 1-hour CRAMs as well. So that would be our first one, our CRAM plus Big Idea 1. There also was CRAMs for Big Idea 1, 2, 3, 4, and 5. And then after that was a create task CRAM. And all of this student handout I did in there as well. So you can go back to the other recordings. If you have questions on that, absolutely at any time, Discord or Slack, reach out to us and let us know. We will help you find the recording if you don't have access to it or can't find it. So you will have that 6-page reference sheet. I really liked it. I've had some of my students every year say, I didn't even use it. True, you might not. But I want you to know it's there, and I want you to have looked at it ahead of time and know what's on it and how it works and where stuff is. Moving right along, this is our create task. Right? Again, we did have a CRAM for it, so I just want to kind of hit the big things, and these are links. Right? So if you want to come back to them or look at them, you absolutely can at any time. So the very first one, again, is the link. The same as the previous page that has the, it's about 15 pages, 15 or 16 pages on how to do the create performance task, how to start to end. Also a create task walkthrough. There is a 1-hour webinar, and if you can't get it to work through here, it's also right on the College Board website. And you can just do collegeboard.org, go into courses, look for create task under the CSP. I like that because some people really would prefer a video instead of text walkthrough. Completely up to you. Also, this AP digital portfolio, you already have access to this, and you have to submit your create task in there. Right? All right. So we are doing amazing. Why don't you let me know if anybody needs more, if I went too fast? Do we need to kind of jump in to anything on the first 14 slides before I move along? So here is my kind of first use of Pear Deck for today to just kind of see how you're doing. So for example, you have, and we're thinking that Pear Deck should be the same. There should be a Pear Deck link on the summary tab below the video in Vimeo. I also put the link right here on this slide. I'm going to give a few seconds to do that. See if you can access Pear Deck. Oh, I'm just seeing. Looks like we may have two. You guys may be so lucky you might have Tejas as well. We might have two TAs answering some questions for you. Now you will see myself and Miss Choi kind of bounce back and forth between the Google slides that we're in right now and Pear Deck. I'm just gonna leaving this here, and then I will switch over so that I can see what your responses are. And then I'll be back because there's not the captions in Pear Deck, so kind of just be moving back and forth just to make sure that you are okay with everything. But I wanted to give you a chance to check that out. All right, so I am just going to switch over to Pear Deck just to see. How it's working, honestly. All right. We'll see. This might give us a different link. We'll see. In fact, I bet it will. So you might have to bear with me while I check out. I am sharing, so you should be able to see this different link. If it is different, we will see. Sometimes Peer Deck will do that for us. Yep, it did. So I apologize for that being a little different. I am sharing. If you can give me a little bit of your thoughts in there. I will come back into the slides and put the new link in there for you. You guys are so good. So flexible. Thank you guys so much. We should really, never know, but we should have like one more little change as myself and Miss Choi switch, and she'll have a different Peer Deck, but we'll see. So that might be affected by this change in the Vimeo link. So we are about 1 hour in, and so my big question to you is, how are you feeling so far? Any questions you have on what I did on like the administrative stuff? Got any thoughts, comments? Okay, awesome. Let us slide back here so I can put into present mode so we can get those captions back for you. Okay, so there we go. Back. All right, moving along. Awesome job on the first hour. You guys are fantastic. There's kind of the administrative, maybe a little boring stuff, but we will jump right into it. So this is where people were asking, can I have this overview of big ideas? Can I have the what's on it, the content, where does it fall, what percent, that kind of stuff. So I tried to do that all on really one big slide. Okay, so this is the slide 16, where if you're not sure what big idea is what's it titled, how much is it on my test, and so on. So remember, we got 70 multiple choice questions that they're playing with. This is the breakdown of it. So that's where you can see where I said, all right, I am going to spend a little extra time on big idea 3 because it's a third of your test, right? So we want to give it kind of its due. So where I had mentioned originally on the slides that I might start big idea 1 in that first hour, didn't happen, which is perfectly fine. We will get big idea 1 and 2 done in the next hour, And then we'll still have a good chunk of time for big idea 3. That's where, people had asked me, can you do some programming, some code tracing, different kind of stuff like that. All right. Good. Moving on. We are going to jump into big idea 1. So big idea 1, here it is. It's called creative development. It's about 10 to 13% of your test, right? So we're talking maybe, 10% of 70, maybe 7 questions on tomorrow's or whatever test that you're taking, right? So what I did is I kind of gave you what each idea, and this will be that way for each of the 5, what the big idea is called, what percent it is, and then on my next slide, what are the content topics? Again, this is what you guys asked for when I was kind of doing those 1-hour CRAMs. I had people asking me, what are the content strands? What are the topics that are on each? Okay, so for this one, for big idea 1, it is 4 bullets, I guess, or subtopics, right? So what I did is I kind of broke that down on the next slide as well. So here's the content slide or content topic slide to tell you. Our big idea 1 covers collaboration in computer science, program function and purpose, program design and development, and identifying and correcting errors. So again, what I have on the next slide is a little more explanation of what each of those are, because collaboration is huge, right? So like a little better explanation. Collaboration is computational thinking practices. How can collaboration in the computer science world and problem-based learning in a job that's problem-based, how can that help us? So computational solution design and responsible computing. Under our program function and purpose, the next one, again, 3 little bullets or mini side bullets. When I look at the questions, this is what the College Board is putting on there. So you have computational solution design, abstraction, which should sound familiar, right, from our create test, and code analysis. That goes along with our pseudocode stuff. Program design and development, we have computational solution designs, code analysis again, right? Understanding that there's definitely some overflow, right, in all 3 of these here. And responsible computing. And the last one, identifying, correcting errors, what we call troubleshooting, right? And computational solution design and code analysis. All right. Moving right into some of these questions, right? So choose an option on Pear Doc. I will read it to you. I know some people kind of move through this quicker than me. A company that develops educational software wants to assemble a collaborative team of developers from a variety of professional and cultural backgrounds. Which of the following is not a benefit of assembling such a team? Collaboration that includes diverse backgrounds and perspectives can eliminate the need for software testing. Collaboration that includes diverse backgrounds and perspectives can help the team anticipate the needs of a variety of software users. Collaboration that includes diverse backgrounds and perspectives can help the team avoid bias. And finally, collaboration that includes diverse backgrounds and perspectives can reflect the strengths of individual team members. Remember here the word not, which is not a benefit of assembling a collaborative team with a variety of backgrounds. So go ahead, put your answer in. Let's see what you think. Nice. Oh, good. I love this. You guys are doing awesome. Good, good, good. Looks like everybody's getting it. Of those, right? I apologize. Let me know if I need to slow down. You guys are doing so good. This, again, because of the word not, right? Collaboration in diverse backgrounds is absolutely not going to eliminate the need for software testing, right? So the need for software testing is not going to be eliminated. Even with effective collaborators, we're still going to need to test the algorithm in the program to make sure that it is giving us our expected outcomes. Great job. Okay, next, moving right along. Right, and I'm trying to notice up at the top, right, these questions here, what you'll see, in case you are new to this, cramming with me, I'm going to hit each of those contents and the big ideas of or the sections, the sub ideas of the big idea. I will give you the full question on my first slide. And a lot of times on the following slide, I will give you, sometimes I'll explain why answers are wrong, why I would not say, because they will always say best describes, not saying that they're kind of giving themselves a little break. It might not be the only right answer, but this is the best one, right? I also, you'll see that each progressive slide that I do, I will kind of narrow down and get rid of some of the clutter of the question, all right? So just kind of be aware of that. You'll see me, I kind of put dots or highlight different things, right? And when we get to the error, looking for errors, troubleshooting, I'll kind of walk you through those as well. So in the following procedure, again, go ahead. You don't have to wait for me. Some people are already answering on Pear Deck, which is awesome. I give you this. It's called a block-based procedure, a little kind of language agnostic. Assume that X is an integer, which of the following best describes the behavior of the procedure. Nice. I love seeing all these answers coming in. You guys are so good. A, it displays nothing if X is negative and true otherwise. Nothing if X is negative and false otherwise. True if X is negative, nothing otherwise. And true if X is negative and false otherwise. Okay, so look at this. Mystery, right, which is not a great name. We talked about how we want good names for our procedures, but they just call this mystery procedure X. So X is less than 0 gets stored in Y. If Y, display Y. Okay, so what we're looking at is X is negative and it's stored in Y. So we are going to find out that it is going to display true if X is negative, because that's what this means. X is less than 0. So I'm looking for something like C or D, and it does not tell me. It just says if this is true. So if you have a negative number stored in Y, right? So if Y is true and it has a negative value in it, display it. It does not say otherwise display something else. So I'm going to go with choice C. Good job. So when X is negative, Y is assigned to the value true and the value of Y is displayed. When X is not negative, nothing's going to happen. There is no display statement that's ever going to be executed. Good job. Okay. Moving, this one is program function and purpose. The next one is the design and development. So program design and development, and you will notice I'm kind of throwing out, and I will always throw the hard questions at you at the CRAM, right? I would love nothing more, both Ms. Troy and myself, we would love nothing more than if the day of the test, you're like, oh my gosh, this is a piece of cake. The CRAM was so much harder, right? So we are pulling the tough questions. We want to do the tough ones with you to move your learning along, right? So in this procedure, the parameters X and Y are both integers. Which of the following is the most appropriate documentation? I don't know about you, but this is something my students would prefer me not make them do, right? We don't always love documenting, but I can tell you, as I was a programmer before I went into education, huge, right? Especially I worked in a bank situation. I couldn't do the entire program just for security reasons, so I couldn't steal all the money, I guess. But they take safety precautions, right? So you have got to document. That is a really big thing if you're thinking about going into something in programming in the future. So in the following procedure, parameters X and Y are integers, which is the most appropriate documentation, right? So as we're looking at this, well, I think even just for math, right? Don't we have a real big issue with we can't have 0 in the denominator, right? So that's the first thing that jumps out to me. I think that I would definitely document something about the fact that if x is 0, this thing's not going to work. So as I'm looking at the choices, definitely seeing that we actually, it's okay, y is 0, so I definitely think x must not be 0. So already my test taking strategies are saying, let's move it down to A and C. It's got to be one of those. Okay? And the next, they moved the parentheses. That's what the issue is. So A is not correct because notice they're going to do x plus y first and then take that answer and divide by x. So I need to do this first or put it in parentheses. So I'm going to go with choice C. Good job. I only saw a couple people. Looks like everybody, which I was wondering about that, right? If you're not somebody that loves math, would you remember that it's only the bottom that can't be 0? Some people, I was worried, would kind of get distracted by D. It looks like the majority of you are giving that x must not be 0, which is awesome. Nobody chose B. And then looking at the order of the parentheses to kind of let you come up with that final answer of C. So the code segment first adds, and so it's pretty much what I said, right? We're going to add x and y and then take that result and divide it by x. So the value of x must not be 0. Otherwise, we would get a divide by 0 error. That would be an issue. Okay? Good job. All right. So moving on to the next one. The next one up says identifying and correcting errors. Sorry, not orders. A homework assignment has 10 questions on it. The assignment is going to be graded as follows. So over here, got this. If you got 9 or 10 questions, you get a check plus. Get 7 or 8, that's a check. Under 7 is a check minus. Right? So let num correct be the number of correct answers for a student. The code segment is intended to display the grade based on num correct. Okay, so this one, just because there was so much writing in it, I did kind of spread it to a third slide. So my first is just us looking at this, but I know some of you are moving quicker and ready for that paragraph. So let me just kind of show you the next slide that allows you to enter. Good, so I'm coming in. For those who are a little hesitant or to join the pair deck yet, if the number correct is greater than 7, then we need to also check, is it 9 or bigger? Otherwise, if it's bigger than 7 but not 9 or bigger, we did a check minus, right? Now I will say, please read, when you're doing this, the reason I have write your response instead of choose a choice is because right here says select 2 answers. So I see some people are just kind of checking 1, right? Good. All right. So yeah, you can just even rewrite the response or back that up, change your response however you want to do that. Or if you just added 1, that's fine. I'm still looking to see if you got one of them right. Awesome. So it says, which of the following values is it not going to give us the correct grade? Okay, well, let's look here. And if we choose 9, if the number is bigger than 7 and 9 or bigger, I got to check close. Okay, that came out okay, right? And great. So 9 does work. Which one does not? If I got an 8, so I do have my num correct. My 8 is bigger than 7. Got it. Then when I check the if num correct is 9 or bigger, it's false, right? So that's going to give us a check minus. So I think 8's not going to work, right? Because 8 is bigger than 7, but not bigger than 9. We're going to end up getting a check minus. So I'm going to walk through that. And again, I see a lot of people gave me the 8 or the B response, especially if you were just check 2 answers. You did great between A and B. Those of you now, I'm seeing a few more people, it looks like. Yep, coming in with the other, which is D, the other correct answer. If I have 7 is not bigger than 7, so it'll jump all the way down here and give a check, which is true. So that worked fine. Let's see. Just getting a little comment on the pair deck is not being synced up. And I'm seeing some responses, so maybe not all. So let's check. Let me move to this kind of while we're looking at it. Kind of checking pair deck as we go, guys, but you are doing well with this. And that's at least kind of, yeah. Okay. So good. So just kind of looking through at some stuff. And if Pear Deck is working for you, that is awesome. And we're going to actually take a kind of brain break in a few minutes, and that'll give me time to like play and recheck. How's that? So we talked about 8 or choice B. I also want to kind of talk about D, which is my second correct answer. Right? So this would be those last 5 or 8 questions on the test where you choose the best 2 answers. When num correct is 6, we look at this and 6 is not bigger than 7. So it actually goes all the way down and gives us a check, but we should have a check minus. So 2 times that it does not work correctly, which is when we have an 8 or a 6. Okay. So that was our big idea 1. And again, that's maybe one of the tinier ones, right? It's about 10 to 13%. So just going to kind of give you maybe, I'm just going to kind of escape out of here for a second. And just going to kind of check. Let me see if I can just update quickly. We'll see. Maybe not. Okay. This is the slide I was talking about where the 10 to 13%. So the big idea 1, definitely that troubleshooting and documentation is something that I'm seeing the College Board put, questions on the test on, but still is one of the smallest. And then we're kind of also going to hit big idea 4 is the next smallest, right? But I wanted to leave about 40 minutes or so to hit big idea 2. But I also want to be mindful of your sanity, and you were amazing the first 20 minutes or so. But I just want to make sure if you need a break, my intent was to kind of give us a full stretch and stuff after big idea 2 to make us make sure before we get into big idea 3 that we're good. Let's see, my link is up here. So let's see if me switching to here might, let's see. All right, so we are looking at big idea 2, which like I just said a second ago, and just kind of showed you the slide. Let me shut a couple of emails just to make sure. Okay, So big idea 2, jumping right into the next one. This big idea 2 is all about data. And it is 17 to 22% of your test score and of that multiple choice, right? And so that is maybe 20% of it, right? Of 70 questions. So that's a fifth of the exam. It's a decent chunk, right? So we want to kind of be thinking about that. And what I did, again, like the others, I broke that down into the little subtopics, right? Which, again, that was people asked for. They wanted to say which content goes in each big idea. So that's what we're doing. So after each big idea, and I explained the percentage, and then broke down the bullets that are included in there, as well as my third or my next slide on this is going to also have like a breakdown of that. What the heck is binary numbers? What do I mean by the compression? Okay. Now I am, just so that I have the just so I have the just gonna go here. Just so you guys have the captions, I'm kind of going back and forth between the Google Slides and Pear Deck. Okay. But I do want to make sure that we have the captions and the laser pointer, and I will just kind of continue to, I'm going to work in a second machine looking at the Pear Deck, okay? All right, so next, the breakdown screen that I just was on a few seconds ago, binary numbers, data compression, extracting information from data, and using programs with data. This is where just gonna use another screen and try to break this down, because I know it can be a little intimidating if you don't understand what they're asking for, right? So again, binary is here, hexadecimal is not this year. So that was another little change. Evaluate solution options, implement and apply an algorithm, and explain how abstraction manages complexity of a program. Computational thinking practices, evaluate solution options. This you see, right? There's some overlap in there. Extracting data, extracting information from data. Computational thinking practices explain how knowledge can be created from the data, right? So that, some people think of it as like a statistics thing. The more data I have or collect, the more useful my knowledge is. Right? That can sometimes be true. And describe the impact of gathering data. And the fourth content bullet for this one, using programs with data, implement and apply an algorithm. Again, you see the overlap from these two, and explain how knowledge is generated from data. Again, this is very similar, but this is knowledge created from data and knowledge generated, very similar. Okay. I am moving into this few problems. Just going to kind of same thing. You'll see that in my sample question, it'll tell which the questions are, and it'll tell which of these content ideas. All right. So sample question 1 for the binary numbers. A certain programming language uses 4-bit binary sequences. And so I gave you an example here in the question, right? 4-bit, 1, 2, 3, 4 means a string of 4 digits. They are binary sequences. So each will be either a 0 or a 1, 4 in length. It is, if somebody loves this kind of stuff, when you have 8, it is called a bit. When you have 4 of them, it's called a nibble. So we have these 4-bit binary sequences representing the decimal value 5. Using this programming language, we are going to attempt to add the decimal values 14 and 15 and assign the sum to the variable total. Which of the following best describes the result of this operation? So you take a second, see if we're having better luck with the Pear Deck. And let's kind of go over, there was some question as we were looking at this. Some people saying that the pair deck is froze. There we go. Okay, good. Now I'm seeing them coming in. So it looks like if we were having issues on the pair deck, looks like I had to come off of the Google Slides where the captions are, but we will catch up in a second. Right, so whether you're watching this later as a recording or kind of reading through it now, and I'm just kind of pausing here to give people a chance because it looks like we're just about halfway there for people who are participating in it. So I don't want to show responses until. Okay, for those who are just kind of like me, almost halfway, those of you who would like me to kind of read that along, you have 0101 stands for 5. Now we want to add the decimal values 14 and 15. We want to call that total. Tell me what's going to happen when we're looking at total. Doing well. Give you about 10 seconds if you want to finish up. Add to that. And I'm going to kind of show it right on this presentation. I apologize. I don't know if what happened before the little freeze up, but I was kind of working a second machine. And so I also want to be mindful that if you want to see how you guys are doing, I was saying, oh, everybody's doing well. Well, let's make it so you can see that as well, okay? Yeah. We're good. We got more than half, so let's kind of look at this. Oh, yeah. You guys are still doing well on this. Good. So the majority of people are correct, saying 95. I'm sorry, saying choice C. Good job. So, again, I'm just going to kind of jump back and forth, but I'll stay on the same machine and see if that keeps us from freezing. So my captions, just so you can still hear me, but I also want you to be able to see the captions. A certain programming language, we already read that whole question. An overflow error is going to happen because when we add 14 and 15, we'll get 29. But the largest binary value that we can do is if all of them are ones, and that is 15. So we're going to end up with an overflow error. Because the biggest that we can do is 15. So as soon as we add anything to that, it's larger. So we'll get an overflow error. Okay. Next, talking about data compression. So which of the following is an advantage of a lossless compression algorithm over a lossy compression algorithm, right? So again, if at any point you need these definitions again, when we get into the further ones, I do toss up, like especially Big Idea 4 has a lot of definitions. So I did bring those into our earlier CRAMs that we've been doing in the last 8 weeks or so. But lossless and lossy I did not bring in. So I think most people, when they hear the language, it's not that bad for them. So when we're talking about the lossless, okay, I always explain it to my students as a picture, whether it's a picture of an ocean or a forest or something. Let's think about an ocean. We have an ocean, there's a lot of blue, right? A lot of that same color. Lossless means that we're going to keep it. We're going to use all of that as is, which is going to be a larger picture, right? A larger memory use. Lossy means that if we could really just take one pixel of that blue or whatever color the water is and just kind of say, yeah, the rest is really like this. So we can allow some ability to make things smaller, right? But when we're done, we really want to be able to reconstruct the data, right? So we can reconstruct the complete with lossless. Lossy, it may be a little blurry when they lose a little. So as we're looking at this, again, can you add it into the pair deck? What's an advantage of lossless compression over lossy? There we go. So it looks like that is. I'm going to have to just make sure to use this, otherwise it seems to be freezing a little bit on here. So what's an advantage of a lossless compression over lossy compression? As I was giving the definitions, I kind of gave it away a little bit. Let's see how you're doing. All right. Let's see what you think. On fire again. Again, like I mentioned, we do try and choose the harder questions, right? I'm going to go back just so we kind of re-see this. You see where I wrote the definitions kind of down on the bottom. Just to maybe explain if you are somebody that didn't get choice B. Right? So lossless compression guaranteed to be an exact reconstruction of the original. Lossy compression is not. Okay. Let's check the next one. Moving into extracting information from data. And this one, because there are two answers, I will, when I kind of flip over to see that response. And again, I'm just going to kind of go back and forth just so I can use the captions as I'm reading it. A student is creating a website intended to display information about a city based on a city name that a user enters into a text field. Which of the following are likely to be challenges associated with the processing city names that users might give as an input? So for A, again, we want two answers. That's why my pair deck is a written response. Users might attempt to use the website to search for multiple cities. Users might enter abbreviations. Lost my captions now. A, users might attempt to use the website to search for multiple cities. B, users might enter abbreviations for the names of cities. C, users might misspell the name of the city. And D, users might be slow at typing the city name into the text field. So we're looking at a student creating a website. Which are challenges? Good. And that's perfectly fine. I'm seeing some people are just entering one answer. But you guys are, as you're kind of seeing in here, you guys are walking it. This is awesome. We got an A, so I'm going to talk through the A answer, but looks like people are getting one answer or both answers. Perfectly fine. Good job. Scroll through the rest. Yeah, the only one I saw was an A. Well, question on C. Good. And I like that because, again, I wanted to kind of talk about some test-taking strategy because we are taking this test, right? I see that? It's pumping out the captions. All right. We want to kind of talk about this as from a test-taking strategy, correct? And I think when we look at this question and it says, which of the following is likely to be challenges, maybe D is not a terrible, it is wrong, but maybe it's not terrible. But if you find the two decent answers before that, kind of distracts you from it, which is perfectly fine. Next, majority of you got B and C or one or the other of them. Right? So I did have some people that put in A. Right? So it says that we're looking for challenges, which are likely to be challenges with processing city names that they might put in. So if they are trying to search for multiple cities, I agree that that could be a challenge, but I don't think that that's the biggest challenge, right? And that sometimes is an issue. That's why I chose this. If we're using the website to search for multiple cities, then we're not actually reading what that website was designed for. And so that can be an issue, but I also think that they're trying to process information and it says one city at a time. Right? So although that could be an issue, it's not really a website issue. It's probably a user issue. Okay? So moving along to this, a student is creating the website, got that. We're looking for the challenges, city names. Users might enter abbreviations, and if those are not kind of put in there, you might, confuse the website because cities could absolutely be abbreviated differently. This might require the student to clean the data to make it uniform before it can be processed. So might actually have to have like a programmer or somebody look at it and make sure you understand it before it can be processed or used. And of course, the issue that if you misspell it, how is that taken by the website? So if you misspell, they're not going to be an exact match to the programming behind the website. So again, student might need to clean or look at any data. So how are we going to be dealing with those problems? Is what they didn't answer this question, but what could be the challenges associated with it? All right, this one a little more involved, just because it's a lot for one slide, right? So this is where kind of I wrote the question as I found this, and then the next I kind of shortened up my question here so that I could then put the choices on the next page. So let me kind of read this with you, and then I'll bounce back to the Pear Deck just so we can see and make sure we're able to get the right choices and see them. Count the number of shows that meet both of the following criteria. 1, it has to be a talk show. 2, it is on Saturday or Sunday. Then it tells us that genre contains the genre as a string. So here's our genre right here. That's going to be stored as a string. And day contains the day of the week as a string, which will evaluate to true if the show should be counted and false otherwise. Okay, so that was where, again, I put a lot of this, and you'll see on the next slide, I just kind of condensed it a little bit just so I could fit in the choices for it. Oops. Boy. Pretty now. And now you're kind of looking at that. I'm going to kind of give you a second here and then bounce over to Pear Deck just to make sure that that doesn't freeze on us and that we can actually see and enter. All right, I'm going to bounce over to Pear Deck. Let's see how you're doing. Okay. Broke our 50% part. It looks like people are still responding. I'm just going to kind of move forward to one slide. I won't give you the answer right away because people are still responding, but I do want to kind of move forward and say, as I was reading this question, right, it can be a little intimidating because I have like a spreadsheet type thing. It's different than I'm used to seeing. I have to talk about genre, which I don't even really know what those words might mean. There's strings. These are called Booleans because they're true and false, right? So this can be a little intimidating. Again, why we chose it, right? But what I did here is I kind of showed, I'll have to go back a second just to see how many people responded, but I was able to cross out C and D. And my main thinking for that is it has to be a talk show and Saturday or Sunday. So the fact that it's an and, anything that isn't a talk show or anything that has an or in it is not going to be correct. So my very first thing didn't really help me because all four choices said genre is talk. Right? But the next part, Saturday or this point here, Sunday, right? So I'm really going to say, hey, probably not C. I also might be able to, kind of say, all right, based on what I just said there, would anybody get rid of A? Because it says Saturday or Sunday. So maybe the piece missing here is this, it's a talk show and it's on Saturday or Sunday, right? So let's look. I'm leaning towards B. Awesome. Nobody fell for D. That's the one that I would hope that we would be able to cross out right away. Good. So absolutely agree. I am going to lean towards waiting for it to catch up. Yep, I'm going to lean towards B. For a show to be counted, genre has got to be talk and day has to be Saturday or Sunday. So it did say on that very first slide, the criteria, it has to meet both of the criteria. So the reason that the fact that it says it has to meet both of the criteria, going back to the original question, has to meet both of the criteria. So that implies it's an and. It has to be a talk show and it either has to be Saturday or Sunday. So you see how it's a little tiny, and I thought this one could be a little maybe confusing or make you think twice or doubt yourself because it said both. It didn't say and, right? So it gave us the or, but it didn't give us the and. So if anything, it made us doubt ourselves a little bit. So because it has to satisfy both of those, I would say and it has to be in between. And then they gave us the or, so hopefully that was kind of helpful to, like the majority of you did, to get rid of A and C. Good job. Okay. So we are through two big ideas. We are doing fantastic, and you guys are so good because we even made up or didn't lose any time on that. So we are right where I would love to be. Just kind of saying, hey, how are you doing? How's it going? Everybody good right now? And maybe I'm just going to kind of add in a question here. If I could, I think it got, I don't know, it's probably on one of the other ones or something, but I want to make that into a slide for you so I can also go over the pair back and see what your responses are, okay? I would love to know how you're doing so far. What? It looks like I'm not getting responses from you, so well, let's see if I can do a. Nope. I don't want to do anything that might mess this up for you. Okay. So I was hoping I could just incorporate that, but I think because I'm already running it does not want to let me do that, which is okay. So if you want to either add to the discussion or unmute and just shout it out to me, that is absolutely fine as well. My intent here is just to give you a couple minutes. Right? Have a little brain break. How are you doing? So if you need to, get up, stretch, do some jumping jacks, go to the bathroom, get something to eat or drink, now would be a great time to do it. Let's see, my computer says 2:52. So, how about we go 5 minutes? So about 2:57, I'll be back. Not that I'll be here the whole time, but I will give you so that you don't like panic thinking that you're missing anything, okay? I'm going to keep this in present mode just so that I can, if there are any questions, the captions will be in the recording and all of that. Okay, so what I just repeated again is I'm going to give you 5 minutes. So until 2:57, if you need to do anything, stretch, take a break for 5 minutes. I am leaving this in Google Slides with the captions on, just in case anybody does unmute, ask any questions, or has anything for me. I want to be able to see it in the recording so anybody comes back to this. So go ahead and take a couple minutes, and I will see you back in about 4 or 5 minutes. This is your 1-minute warning. And I am just playing with my captions. There. So I just wanted to make sure captions are still working. I will resume here in about 10 seconds. Okay. So here we are. We are starting up and we are on to big idea 3. So this is the big one. 30 to 35% of the multiple choice questions are going to fall into. Hang on 1 second. I'm just working on the behind the scenes for you guys, so we make sure everybody's here for it. All right. So this is big idea 3, and I always tell my students, if in doubt, this is where it is. Right? So if you're not sure on how to do something, or you are looking up practice problems or anything like this, chances are it's a big idea 3, unless it's one of the other topics I've mentioned. But this is the one where we're following through on pseudocode, and there are like 18 content ideas here. Okay, so I'm going to spend a little more. If you were able to be at the 2-hour CRAM, we actually, extended, Friday will extend this to a 2-hour CRAM for you back a few weeks ago. I'm going to use different questions. So some of the slides will be repeats on like definitions and stuff, but the majority I brought like different questions in, unless they were the hardest I could find already. But we're looking for the challenging questions so that, again, the day of the test looks easier. That will be our hope for you. So, big idea 3, algorithms, programming, 30 to 35%. So you get one screen on the next one, and that is because there are 18 content ideas. So this one is huge. All right. So as we're looking at this, I am going to read through them just so we catch it all in the captions for you. So as we're looking at this, again, there are 18 content topics: variables and assignments, math expressions, Boolean expressions, nested conditionals, developing algorithms, binary search, developing procedures, random values, algorithm efficiency, data abstraction, strings, conditionals, iteration, lists, calling procedures, libraries, simulation, and undecidable problems. Okay? So without too much further ado, I really want to kind of jump into problems because, of course, as you can imagine, There are some cases I do have more than one question, but we're talking at least 18 questions to get through, right? So I do kind of intersperse every once in a while. I will shorten questions, talk to you about how I think the test taking strategy can kind of help you, how to eliminate some of the choices, get the best choice, will be still using Pear Deck, and then we'll take another break because this is a long one. And then we will do Big Idea 4, where it's a little bit more definitions. Okay, so I'll be tossing in some ideas for that. So this one, variable is open. The variable called is open is going to be used to indicate whether or not a store is currently open. Which of the following is the most appropriate data type for is open? Okay. I'm kind of giving you a second here if you want to pop your answer into Pear Deck. I will wait about 10 seconds in case you're looking at these and want to answer right away. And then before I give you the answer, I did just write out the definitions for each of these for you, because if you're struggling for that and taking the test tomorrow, we want to kind of make it easy for you. I don't want to leave tons of things you got to go ask Siri the answer. Okay? So let's move on to the next one where, again, before I give you that correct answer, I just kind of wrote out some definitions for you that I hope were helpful. I'm looking at a variable is open, and I'm going to use that to store whether a store is open or not. And you may have seen this even on Waze and Google Maps. When you look up a business, it'll say it's closing in 20 minutes, or it may be closed before you get there. That's what we're talking about here. So what kind of variable would be the most beneficial? A Boolean variable allows for two options: yes, no, true, false, on, off. For a string, string is going to be allows for characters to be together, kind of like a name. C allows any number, integer, decimal, etc. And a list allows for a list or a group of values. So how you doing? I'll give you a second so you can get in these answers. All right, let's see. Not tons, and it absolutely could be maybe low on the response if people are slow coming back. But please let us know if it's more of an issue that you really don't know, need a little extra help, or again, if something happens with that Pear Deck, okay? Good. All right, let's see how you're doing. Absolutely good. So everybody recognize if we're asking if a company is open, we're not using a number. So that is fantastic. Good. All right, and so I was just kind of like looking at the other choices that people did kind of choose. So I agree that that is outstanding that nobody thinks numbers. So very pleased with that. And just kind of want to talk about why the thoughts would not be string and not be list for this. So string is going to allow characters to be together like a name. So the distraction could be if you thought is open would store a yes or a no, for example. You would be thinking string could be YES, the three letters together. Okay? Um, and list used more in the CSA class and the Java class. So we do deal with some lists, but for this one, really, we're going to stick with Boolean. Okay? And let me show you. I'm going to hide the responses. We'll jump back here for a second. All right. So here are my definitions again. Which of the following is the most appropriate data type for is open? I absolutely would lean towards A, okay, because A is my Boolean type, which is the store is either open or not open. There are only two options for it, and that's the nice part about Boolean. Okay? I would say, like I mentioned when we were back in Pear Deck, number would be my least likely choice. Okay? And between the string and the list, I kind of explained already. And I was able to add in a Pear Deck kind of slide for how are you feeling right here. So Pear Deck question, how are you feeling? Did you have any questions you would like to ask after that, the two ideas that we've done so far? So I'm going to kind of just show the responses so that I can look as they're coming in. Also, feel free, let me know if I'm talking too fast, too slow, anything else that you feel you're not getting answered to. Yay, I love Boolean. So Boolean is the favorite topic in computer science. That's outstanding. Awesome. I was in the majority of these questions are not too hard so far. And I love that too. I love that response because I'm picking the hard ones, right? Yeah, still nervous about this exam tomorrow. And I am super hopeful that you will feel so much better by the time we're done with the big idea 5. And hopefully you're okay with this. That we will absolutely be here for you for the whole time to get through everything. And so because we had those little technical issues at the beginning, we will be here until it's done. So if we run a little late, that's absolutely fine. Okay? So we will, don't worry, we're going to kind of get the whole 5 hours in. We'll make it all up. Doing the questions, doing well on the questions. I'm worried that the questions are easier. No, I am choosing questions that are the harder ones. So you are absolutely, this is awesome. And that's what someone would say, oh, I really would like to just do easy ones the day before. Yeah, but I really would like you to think that the day of the test is really easy. So it is true. We're going to, both Miss Choi and myself, we're going to choose the harder ones. Just means that you're doing well on the topic so far. So I wouldn't say that I'm choosing easy questions right now, but you may find that you're just really good at these so far. These are definitions and topics that you're good at. And I got some challenging ones coming up too, right? So we got like faultless, lossy losses. We got some stuff that will challenge you maybe. If not, that's awesome, right? And that is fine. I had somebody say, I'm doing well so far. Yes, you can get the slides, absolutely. So you have access to the slides because you paid for this. So because you signed up for this and you have access to, you then have access to the recording of everything. and this slide, so you can come back to it whether your test is tomorrow or later. So if you do need to leave at some point, absolutely, you can have access to those. Good, yay, no questions wrong yet. That's awesome. Nope, I'm gonna pick the middle of the road up to the harder ones. You'll see. Good, most of these not too challenging. Good, correct, awesome. No, we don't want anybody to be mentally dying. We'll get you through it. Believe me, the first half hour, I was probably there with you. Nobody wants things to like not go well. So we're okay. Good. Feeling prepared. Good. This would be, why are numbers the least likely? Okay, on the last question we just went over, because the is open. We're trying to see, is a store open? And so number would just give 5, right? So if we're trying to see, you want to check, like, you ask Siri or you check on Google, is a store going to be open? What time does this store close? Do I have time to get there or not, right? So I don't want them to give me 5 back, which might tell us 5 p.m., but our variable is just is open. So we're asking for a yes or no, not how many hours until it's closed, or not what time does it close. So that variable, the is open, really is just going to have 2 options. It's either open or not. So on that question, I'll go back to that slide in just a second. Yeah, of course. And so it's not what time does it close, right? So I'll go back to that question just so that we see that. That's awesome. Good. Yeah, I thought so. I'm hopeful that doing questions is good for me as well, I think. Yes, your brain's turning to mush. This will come and go, right? And so those brain breaks every hour, deeply important, right? To get up, shake your head a little bit. Good. An example for a string would be the plaza or the address of that business, for example, right? Or if they wanted to, in the is open, is it YEX or NO? Okay, so if we were going to put letters into an answer, a number again would be how long until, right? Enter the number of minutes until it closes, or what time does it close. But if you were doing a number, it would just be 5. You wouldn't be able to do 5 p.m. or 5 a.m., for example. And a list, usually our list is really going to be saved for multiple values. So if we took all of the businesses in a plaza and asked yes or no for each of them, going from one end to the other, that could be stored in a list. Okay, so great questions on can I clear up some of those. Good. Yep, and I think I just did. And a string would be the street address of that, or the word YES. Yeah, those paragraph ones, especially like, I'm somebody that I don't want to read if it's a long paragraph, right? I want to have nice short questions. Boolean, yes, Boolean means yes, no, true, false. So when I say with this store, is it open? What I'm looking for is the calculator or computer would store that as a 1 or a 0. So if you ever look on a light switch and you have a 0, which is the off, and a 1, which means it's on, so circuits and kind of things like that, that's Boolean. So a Boolean has only 2 options, yes, no, true, false, on, off. Okay, so in this case, my variable called is open only has 2 options. It wasn't what time will it open or how long until it closes. It is just a yes, no, is it open? Yes, we are going to do some pseudocode. I do know that's a huge thing. Good. This session tentatively was supposed to be from 1 to 6, and we're just kind of messaging as you guys are on break that we will go until we get it done. So if you're cool to hang out until 6:30-ish, that is fine. Miss Troy is kind of good. And the main thing is, if I need a little extra time on Big Idea 3 to get everybody, feeling good about this, we may run a little over, right? So it's about 20 minutes of that technical difficulty. So just saying, if we need to be taking an extra half hour at the end, we can. Okay, good. And that's good. So seeing if I'm going too fast or too slow. Stressed. All right, I get it. We'll get you there. Might be going a little slow, but understanding everything, yeah. And that's always tough with over 200 people, right? But we will. Good, good, good. All right. I can absolutely go quicker as long as on the other end somebody says, easy, let's go. Awesome. Good. One wrong so far, but feeling good. So that is good. I'm just going to kind of scroll through. Um, these questions are coming from different review sheets that I have and some right from College Board. So I've been teaching the AP principles for a while. There are some like how to get a 5 on the AP, and there's different places I'm taking these from. Just because I don't want to give you all questions that you might have seen in class, right? Yeah. Okay. So on one of the breaks, or if you need help on that performance test that I can answer anything, let me know. Good job. You guys are doing good. Okay. So I'm going to move on to the next. And just don't let me fly through too much code. Okay. So if you at some point just need to message, then I'm kind of keeping track of things also on my I got 2 computers and my phone going. So if I do go too fast, you feel free to slow me down. Okay. So I am, just because we're moving a little quicker, I'm going to stay in Pear Deck for this, just so you can start. Yeah, see, you guys are entering before I'm even reading the question, which is awesome. Okay, but we are getting a little more into variables assignment pseudocode, so do not panic. Make sure you let me know if I'm going too fast. This one is, for example, I'm going to trace through this code. So some people are doing awesome and already answering. Give you a second to read it. And then what I'm going to do, like I said, is I'm just going to kind of use a couple screens to trace through and see what happens. Some people do really well on this and some people struggle. So I did start with an easier one here, just storage, right? And what does this mean? Which of the variables have 50 in it after running these 6 lines of code? Good. So I'll give you about 15 seconds, to get a few more responses in here. But then, because people said don't slow down anymore, right? I also want to be mindful of that. So let's get through some of this stuff. All right. So looking through here, I'm not changing. So you can still be adding in questions, and I'll go back and look at those responses in a few seconds or in a couple slides. But I want to kind of look at this and see. So my first assignment here is saying 25 gets stored in a box called X, 50 gets stored in Y, 75 gets stored in Z. So those are what I call my initialization, my first few things. Now each variable can only have one number or one value in it. So looking at the next, what happens? It says take the value from Y. It doesn't mean get rid of it. Make a copy of the 50 that's in Y and now put it in X. So that's how 50 ends up in X. Then take the Z value, which is 75, and put that in Y. So Y is no longer 50. And then take my X value, which by the way is 50, and put that into Z. Okay? So a little bit of kind of playing and showing you how I got that. So my answer is C. I'm going to go back to the Pear Deck and see how you guys are doing. Less responses on this, but those who did respond are getting C. Right? So good. And again, I don't think it's that they're getting harder, but for some people, traveling through these pseudocodes and kind of tracing through is the issue. And if you think about it, that almost is like human nature. We're okay with writing a paper, but then when we have to go back and debug it or write another draft of it, it's where we don't like it as much, right? So when we have this, reading through and tracing through the code sometimes is not a favorite. Where you write a program and when you're done, you're done. I mean, you hit run and it gives you 5 errors, you don't want to do it anymore. It doesn't sound fun, right? So that kind of is human nature. So how are you tracing through? I tend to trace in what I call like a T-chart. I just kind of wrote out like a little chart like this and cross out as each value changes. I just kind of keep track of it that way. All right. So that one, like I said, my answer was C. Next, I am just giving you a couple definitions before I move into the next slide. So my next slide is going to be data abstraction, but I thought that that would be a good thing to spend some time on because that is sometimes something that abstraction in lists, and I thought a comment earlier could I give an example of it. So that, not like I was ignoring, but I knew I had that kind of covered in my slides here, okay? And I do spend a little time with the definitions coming up just because I know that this is tough. So abstraction is preserving information that is relevant and forgetting about the stuff that's not. Right? So it says preserving. Abstract is preserving information that is relevant and forgetting or ignoring information that we really could say is irrelevant in the context. List. List is a data type that represents a countable number of ordered values stored in a single collection where the same value can happen in more than once. And that's where I gave you the example of the plaza. So if I think of like a shopping mall or a shopping strip where you have all these different stores and each element of the list is the time that they open and the time that they close, that would be a decent use for list. So a basic idea or example of containers, they have values that can be added to and removed from. If they are number values, they could even be added or compared with each other. So how many more hours is this store open than this store? Right? So that would be an example. But those two at least are definite definitions I find that my students need me to go through a little bit more. All right. So a question about this data abstraction. Again, move at your pace. So if you see this question on Pear Doc, feel free to kind of start answering. Programmer needs to round number values to the nearest integer. Which of the following best explains the benefit of using a list as a data abstraction? Multiple choice, one answer. I want to round numeric values or number values to the nearest integer. Which one explains the benefit of using a list as an abstraction? And I like some people are saying I did better now reading these paragraph ones and ones that have a lot of words on it, not as intimidating, right? So let's kind of look through this. And what I did is I explained why the three answers I didn't choose first. So as I'm looking a little slower on the responses right now, which this is a text-heavy question, right? So reading the choices, keeping the numeric values in a list makes it easier to round to the nearest integer. The algorithm to round, just kind of talking through here, as you're making the choices. The algorithm that I round with doesn't change whether I use a list or not, so I'm not really leaning towards A. Keeping the number value in a list makes it easier to apply the same computation to every element. That's absolutely true. If you think about a spreadsheet and I want to double every value in there, right? If it's in a list, I could just think of it as a dilation, the entire thing, just by multiplying it by that list. So B could definitely be a runner here for the answer. C, keeping the number values in a list makes it easier to prevent the program from unintentionally changing the value of a variable. Nope. How you store it is not going to change whether a program changes, gets rid of something, within there. So it's not that a list is more secure, for example, you think. And D, keeping the number values in a list makes it easier to prevent a program from attempting to access an index beyond the length of the list. No, it would make it more likely that the program could access beyond the length of the list, not less likely. So I don't really agree with D either. So I would say my next, looks like we got a few of these. So how'd you do? Good. A little more confusion on those, and that's why I'm going to go back to my slides, but still seeing majority of people are saying B, which is awesome. What I did here is I kind of wrote in different thoughts for each of these. So algorithm that rounds does not make a difference if it's a number or in a list. Doesn't make a difference over where it's stored at all. It said I do like B. Using a list does not prevent a program from changing the value of a variable. So it doesn't have anything to do with it. And introducing a list to a program makes it more likely that the program will attempt to access beyond the list, not less likely. Right? So those of you who got B, absolutely agree. That would be the one I went with. So I put a couple things on my thoughts with why I'm going with B. Using a list as a data abstraction can result in a program that's easier to develop and maintain. Right? Once I create that list the first time, I can keep adding and taking values away from it. I don't have to recreate it again. Or to come up with another variable name, for example. And it's easier to apply the same algorithm to every element. Like I mentioned, the dilation. If I want to multiply every element, double every element, then it's easier to do if those are in the list. Okay, decent. Let's go to another one, and I am gonna stay in pair deck because my very next slide is a pair deck. So since we're already here, let's stay in here. Give me a second to read that, and then I'll kind of talk through it. It looks like people are popping in their answers here. If you are given some code, what are the contents of your list after the code segment is executed? So we have a list, right? Because lists I know are something that can be a little challenging, right? So the next couple slides are just a trace through of it, like I said previously on the other one, because I think that it is helpful for you to come up with a way to trace through this stuff. So 20, 40, 60, 80 are stored into something called your list. 10, 30, 50, 70 stored into my list. And then it says my list goes into your list. It says what is going to be at your list when this code runs. So when you're done, what's going to happen? Right? So I am going to take a gander at the responses just to see how you did. And then we will, for people who are confused on it, go through that as well. All right. So what I started out with, I just kind of took the choices away for a second and said, all right, how this starts out is 20, 40, 60, 80 gets stored in this container called your list. 10, 30, 50, 70 gets stored into a group or a box called my list. Next, that's my first two, right? So like my initialization. My next one says your list now is replaced with my list. So I take the contents of my list and I store it into your list. So I get this 10, 30, 50, 70. Now the code is done. So that is the result. So I would go with choice A. So great job, those who got A. And I want to be mindful about those. There's only a couple of you, but I also want to be mindful of, coming soon and after the next question I ask you about, do you know what something means? And when I talk about that, I'll also say, are you feeling okay with this? Or do you need anything else? How can I help you explain anything better? Okay. So my next question, the AP exam does seem to ask you, do you know how to swap values? So I wanted to kind of talk about swapping values because what I find sometimes is you just kind of think about if you were walking up to a person and you swap, a bologna sandwich for a turkey sandwich or something like that, and you can just exchange it, right? But it doesn't work with computer science. So I'm going to go back a slide and show you here, right? Only one thing can be in there. So once your list is replaced with these values, this is no longer in there, right? Also, once my list writes over into your list, these values are gone, so I can't just swap them, right? So big thing is when I'm swapping values with computer science, I need to think about a temporary folder. So the reason I say that is A is going to be my first rejection on you. Okay? And I did not do Pear Deck for this because this is really just me saying, are you okay and do you know how to work this? So yes, it is a multiple choice question, but I find that so many I'll repeat it one more time. I find that many of my students coming through the principles class don't realize that, where can I and where can I not. So I did not make this a Pear Deck just because I wanted to explain the idea to you of how you swap values. Right? So which of the following would interchange the values of variables num1 and num2? So I think I've probably already given the teaser enough or pretty much said it is not A. It's not done how we humanly could do that, just swapping two things at the same time. Once something is gone, it's gone. I can't really put it into the other. So my big thing that I always tell my students is that you have to have a temporary storage location in order to swap values. So it is not choice A. Right? I am kind of stalling a little because the other choices are kind of close to each other. So I absolutely do want you to see if you could come up with the correct choice. Because they're very similar to each other. Now, what I did on the next screen, on my next slide, is kind of explain the other two incorrect answers and why they wouldn't. So if you are somebody that you kind of are looking at this wondering if your answer is correct, B is the correct answer. I'm first going to explain how come it's not B and C. So what I did here, again, I really like the T-chart. So if you are somebody that you're working on this tracing through code and you don't have a way that works for you already, you may want to think about this. Okay. So I start out here. Choice B says put num1 into temp. So we originally start out with, I got num1 and num2 in their spots. Right. So it says take num1 and put it into temp. Okay. So take num1. Put it into temp over here. Okay. And then it says take num1 and put it into num2. Num1, put it into num2. Okay, but that didn't really finish or do anything for me, right? So it didn't swap out like what my new num2 is going to be. Num2 really didn't do anything. And on the next one, line C, again, I got num1, num2, and 10. I'm going to put num1 into temp. I'm also going to put num1 into num2. But the issue is, I then num2 is gone. I've wiped it out. Because I put num1 into both num2 and temp, this value is gone and cannot then be moved into here. Right? So they're both similar in the way that it's not going to be effective. So what I did here is I kind of broke this down a little bit more, but I said the first statement, so let's assume the first one has num1, num2, temp, each of those variables. Now the first one is going to assign num2 to go into the temporary storage, which is good, right? Then it says take num2 and put it into num1. That's the difference between this choice and choice C. Okay? The third statement is going to take the original value, which are going to be from temp back into num2. And then I'm able to swap them out. So I thought that this question was a little confusing because they're so close. So what I want to do for this is I just want to go back to the original. We already said, and I'm hopeful that the majority of you could say it's not A, but between B, C, and D, the difference or why it is D. These are pretty close to each other. They both, all three of them start with the same thing. Right? But this is putting my temporary storage into num1, not num1 or num2. I want to swap and end up with num2 in here, which it never is. So at some point, B is wrong because at some point num2 or temp has to go into num1. And even though temp goes into num1, I didn't put num2 in there first. Right? So it's just the temporary storage happening to C. And then C, I talked about how it just took the num1 and put it back in, or num1 got moved to num2, which is good, but in so doing, it then wiped out num2, and num2 is gone, so it never ended up making it into num1. So choice D is the right one. I do now move my cursor in case I ever need to know something to kind of take a picture or something to kind of re-digest that reader, which is perfectly fine. Okay, so that's where I said, all right, D is my correct answer. And it is, it's not that well, for some people it is that these questions are getting harder, right? Just because the topics are getting harder. So that's why they're newer. The beginning big ideas 1 and 2 are a little more common sense to most people. And I feel like you can even do those without being taught stuff, right? So big idea 3 is where temporary storage, lists, Booleans, some different definitions kind of are big in big idea 3 and 4. Okay? All right, here we go. Time to write another response for me for Pear Deck. My question is, do you know what mod means? But also, if you have anything else to say, feel free. Mod stands for modulus and modulo. And while I'm giving you time to do this, I'm going to pop over to Pear Deck in about 10 seconds, check out some of your responses, and if you are needing anything else from me. I'm also then going to be moving, because the next slide is going to be a math question with mod. So as you're looking at mod, really what mod is kind of weird to some people. It is, what is the remainder? Okay, there. Populating the responses. I'm going to check in here and see how you're doing. Yes, some people are new. Awesome. Good. When you divide a number, let's see what that's going to be. Awesome. It is the remainder. Not really, and that's what we're here for, right? It means to get a remainder. So as you're writing, yeah, of course, we are reviewing. We got you. So perfect. I love this example. I was just going to kind of write one through. So if I take Good. Looking at this. This is awesome. So 4 mod 2 is 0. And those who don't understand it are like, yeah, that didn't help me. Think about any even number. If I divide an even number by 2, the remainder is 0. So although this says 4 mod 2, it could be any even number. 244 mod 2 means that whatever number you take first, divide it by this, and your answer is the remainder. So any even number mod 2, the answer will be 0, because if I divide any even number by 2, it goes in evenly. So if it goes in evenly, that means there's no remainder. If I take any odd number, mod 2, the remainder will be 1. I do want to be clear that the answers are not just 1 or 0, though. Okay? So, for example, yeah, this is all about the... Good. I don't know how to calculate it without a calculator. Good. It is the percent key, which is true. And what we're really doing, if you think back to even elementary school, doing long division, for example, if I take, I don't know, let's take the number 25 and divide by 3. If I take the number 25 and divide by 3, that's going to give me, what, 8? And so if we do our long division, or, if we do any kind of division without a calculator, perfectly fine. 3 times 8 is 24. I would need to add 1 more to get to 25. So if I do my mod function, 25 mod 3, means if I take the number 25, divide it by 3, what is my remainder? My remainder is going to be 1. If I took 26, right, I still would get that same kind of answer, 8. So what times 3 can get me as close to 26 as I can? It's still going to be 8, which is 24. Now I have a remainder of 2. So I would say 26 mod 3 is 2. Okay? Good. Yeah, so remainder. And so that's what this is good. This is kind of what we're looking at. Again, I got zeros and ones. And I am, we either see MOD or the percent for computer science means mod. So what I want to do is I want to give you an example so that you see what this thing looks like, okay? So, for example, this is the next part called math expressions. And so I am going to, again, I'm going to hit the easy ones. I think most of you can do the add, subtract, multiply, and divide, right? It's the mod. If we see this show up on a test question, I want to be able to do that. And some of you need to see that. So I have kind of a couple math expression questions coming up, tracing through, doing mod, this stuff that I know that we need a little bit of help with, right? So there's going to be two math expressions here. The first one, I know that my students kind of sometimes suffer or get confused on the mod function. So looking at this, consider the following, and you can absolutely do it. I got some people answering already. Consider the code. Put 23 into X, and now tell me that Z is going to be X mod Y. So my first thing is like, well, great, but I've got 23. Where's the rest of it? So the confusing thing for some is how this test question is down here, right? They didn't kind of put it over here where it was easily seen, or it's not part of the procedure or the code. 23 goes in for X, 2 goes in for Z, and it's actually asking for Y. So not only do you have to know mod, but we kind of have to figure out that they're not asking for the mod, right? They're not asking for the remainder. They're asking for what could I divide by so that the remainder will be 2. So I thought this was even a little challenging if you did already know what mod is. So what I'm looking at here is 23 divided by what gives me a remainder of 2. So I think, all right, 23 divided by 1, anything is divisible by 1, right? So that's going to give me a 0. If I do 23 divided by 2, it's an odd number. So my remainders for 2 are either 0 or 1, and that's it. All right? I'm going to skip 3, or skip C for a second, because that is the correct answer. But if I look at this one, if I do 23 divided by 24, okay, so think about that. If I do 23 divided by 4, What do you get? 6 is too big, right? So we should be getting 5. 5 times 4 is 20. So isn't that division a remainder of 3? We need a remainder of 2. Okay? Well, let's see how you guys did. Excellent. Good. Good. A little bit on that confusion of division by 1. Anytime we divide by 1, we will get a remainder of 0 because everything can be divided by 1, right? And the part B, or choice B, tells me that we're doing really well with division by 2, which is 0 or 1. We won't have a remainder of 2 in order to by 2. Good. So my next slide kind of clears that up a little bit, I think, or hope. When I divide 23 by 3, the remainder is 2. So I say 23 mod 3 is 2. What I really mean by that is if I do 23 divided by 3, right, isn't that going to be, what, 7? 7 times 3 is 21 with 2 left over. So that's what we're talking about with the mod. Okay? And next one, I'm going to kind of walk us through this next problem. So I'm going to switch back so that we can have our captions on. What I did for this next one, all right, so we just walked through the mod. So now we do know what mod means. It means the remainder. There's our answer. Now this next one, I'm taking a few slides. I'm going to walk through it. So you may want a piece of paper or something. I'm going to kind of walk you through how I would trace through this with the math expressions, especially because I thought this was tough because some of my students messed this up with the order of operations here. And then near the end, right after we kind of traced through it, then I'm going to kind of ask you, how did you do? So another little section to say, how did you do? Did you get it right? Did you not get it right? So you can absolutely trace through this a little quicker than me and get your answer a little quicker. And the next page has our choices, right? But again, I'm choosing this long one, so it might be a little intimidating to some people. I have this code segment long, right? No parentheses, so I got to think about my math, order of operations. What happens? What displays when this code runs? So I'll help you and say it's not an error. So I'm going to leave it here for a second. And like I said, what I'm doing a little differently on this question is, you'll notice how I said, I kind of, once I see what the question is, what displays when the code runs, that to me, this is the actual question. Consider the following code segment. What displays when it runs? And I'm like, okay, that makes sense to me. Now it then says, now it's time to trace through this code. I do so without these choices. So you'll see on the next screen, I just going to take the choices away for a second, just so they don't distract me. I'm going to trace through those first 5 lines are just really initialization. So I'll start with my initialization, and then these next 3, that'll give me my final answer. The display will be all A, B, C, and D all in one, right? So here's the question and the choices. You absolutely can kind of do that on your own. I'm going to step through each and talk about them kind of in baby steps, just so anybody that has no clue can work through this. So my first 5 are my initialization. For me, again, I use what I thought to make it like a T-chart. I'm just going to kind of say each of the things that's given to me, those first 5 are my initialization. My next says X plus B. So I can go here and I say X plus B, 20 plus 20. That is the new value that's going to be stored in B. I have 20 plus 20 is going to be stored in B. So I crossed out my previous value because that reminds me it's not a list, it's a variable. Right? It can only have one value in there at any given time. Next line, I kind of did that as well. X plus 1, so 20 plus 1 is 48. Okay, so I have those two steps. This is the one that I wondered if people would make a mistake. Well, I know that some did because I gave it in class. So order of operations, division has to happen before addition. There are no parentheses here that say C plus D happens first. So the issue becomes, did you remember that? So I have some saying, this is a computer class. Why do they have to do math? They just do. It happens. So I need to do my division first. So my division first is going to be D divided by 2. 40 divided by 2, which is 20. Right? Then my next step is to take that answer, 20, and add it to my C value of 30. So 20 plus 30 is 50. That now is going to replace what was previously in D. Right? So what I did there for my last step, my display value, it's saying display A, B, C, and D. I highlighted those. It's going to, and I do like to do that also because is it displaying A, B, C, D or A, D, B, C, for example? You still need to be careful when you're reading that. And see how you did. The next slide gives you the answer and it says, how did you do? So I'll pop back into, were you able to trace through that with me? And how'd you do it? Were you able to get choice D? Yay. Good, good, good. Awesome. I love. Don't be shocked. You're doing good. My teacher used to say computers are dumb. That's not bad, right? And I've heard somebody say the computer or calculator is only as smart as the user, which is maybe insulting sometimes, right? But the computer cannot make any assumptions, right? It's not artificial intelligence. It doesn't pick anything up from or build on it. They are just dumb as a brick because they have to follow the code as you told it. Mess up parentheses, good, and that's why I picked this one, right? Awesome, awesome. Good, good, good. Forgot the order of operations, right? PEMDAS, parentheses, parentheses, exponents, multiply and divider on the same level, and add and subtractor on the same level. The other sense made sense. Good, good, good. I got it correct. Good, I got A, B, and C, but the parentheses thing, right? And that's why, yes, there's our parentheses, you got it. And that's what they won't explain, right? They won't say, don't forget order of operations. So, yeah, and they're good. So now this is it, right? This is where, of course, this is where I want to pull the hard ones, right? Yes, your brain is 110%. So some people are saying, hey, super easy, right? I don't understand how I got 50 for D. Yep. Let me jump back to that, write it down step by step. And that's what I have to do. Yeah, that's what I like because I do kind of treat it how the computer is going to do it. Yes, absolutely. These questions are the correct difficulty. Yep. If anything, if I'm just my enemy, yeah, if anything, I want your test tomorrow to look easier than what I'm doing today. So the how did I get 50? I believe it's probably the order of operations. We so many times do things reading left to right? But in this case, order of operations says division has to come first. So the D, going back to the one before, the slide before, D is 40. I'm going to do 40 divided by 2 and get 20, and then add it to the 30 that's in C. Okay, so I believe that that's probably the confusion. All right. So moving right along, I do have another definition, but I'm going to stay in Pear Deck because this is what you guys were asking for a little while ago on Boolean. Oh, I'm sorry. String concatenation. Then I do that Boolean again, so make sure we're all good on that. So, question or another confusion sometimes can be what's the difference between a string and what does concatenate even mean? So concatenation is like adding, but when we have letters or words, or it could be digits, like in a zip code, for example. All right. But a string is a sequence of characters or letters or numbers that are a literal constant. And what I mean by that is I cannot take two strings and add them together and get anything more than just shoving them together. So I cannot take N and A and all of a sudden add them together and get G, right? Or I can't take A and B and add them together and get D. Right? So there's a difference there. It's a sequence, and sometimes we can talk about characters being integers, but if I take the integer 1 and the integer 2 and concatenate them, because if they're both sort of string, now my concatenation is going to be the number 1, 2, not 3. So we can have integers, or we can have values stored as string, but the math or the operations that we're allowed to do on them are different. So just kind of taking a second to point that out to you and talking about strings here. So my next example, I'm going to flip to, or I'm going to stay with Pear Deck, but talking about the concatenation of both the first name and initials and last name and stuff like that. So that can be kind of confusing because if they put on the exam, if you have a string of 1 and a string of 3, what happens when you concatenate or add string 1 and 3? It's going to give you string 1, 3, not the number 4. So we do need to pay attention to our data types that they're talking about. So here's my question. Consider the following procedures for string manipulation. Variable initials is going to be assigned a string consisting of the first letter of the string first name, followed by the first letter of last name. Which one will correctly give us initials? Okay, results are a little slower coming in today, or for this question anyway. Good. And it could be, some of the little low response here. I'm seeing 77 out of all of you. Oh, they were coming a little bit more. Whether it just takes you a little longer to read it or you don't know, and that's okay. So let's just kind of look through this one. Concatenation of strings. is going to return a string consisting of string 1 with string 2. If we have the words key or the string key in the string board, we put them together. Concatenating means plumb them together with no space or anything between them. A prefix of a string length returns the first length of a character. So, for example, if we have prefix delivery 3, it's going to return the first 3 letters, and prefix delivery 100 means 100% of all of them, right? Which will return the whole word. So, based on those two procedure calls that they're explaining to us, which one then would work to give us the initials returned, right? And it could be, for me, if the answer is the first one, which in this case it is, choice A, sometimes I'm like, oh, that's probably too easy. I probably did something wrong. And it takes me longer, but even though A was the first answer, was the correct answer, I still want to look through and read all it. So let me see how you did. Good, still majority kind of pushing through with A. Let's talk about those. So all of them have something stored in initials. And we said initials is the first letter of your first name, the first letter of your last name. So putting together or concatenating, right? Prefix, take first name, the first letter, and last name, the first letter. And that's what this prefix procedure call is defined as for us. So that's why I'm moving towards A. If I look at B, C, and D, because I did have a couple people choose each of those. Prefix first name 2, that's going to take my first 2 letters of my first name and last name. So not B, too many. And then C says concatenate my first letter and my my first name and my last name, put them together. Okay, so think of your first name and your last name, put them together. So for me, it would be Marcy Boyd all shoved together. And then take the first 1 letter, so it would just be M, right? And then D might work, but it depends. And what I mean by that is, for me, it would not work. But if you are somebody that the second letter of your first name happens to be the same as the first letter of your last name, you would get lucky and it would work. But for me, if we take Marcy Boyd and put it together and take the prefix of the first 2 letters, would be MA when I need it to be MB. So in this one, if I take the prefix, my first letter of my first letter of my last, and then concatenate those, that's where we're going to have it. Okay? So that's where I put here, the statement will correctly form the initials. It will use prefix to get the first letter of each, then concatenate to put them together. Okay? Now, I did have, and I know that Boolean is something that we talked about, right? But I also want to hit that again because it is another idea in the big idea 3. It's another one of those content strands. So I do just want to kind of toss out another couple examples for Boolean. So I have 2 problems just to get a little more practice with Boolean here. And I am going to stay in Pear Deck for the next couple slides. I apologize on the ability to show the captions, but I do have you a little interactive for these Boolean stuff with 2 problems. So to attend a camp, a student has to be at least 13, and this is one of those that as I am looking at this, as the questions get harder, I'm going to highlight the things that I need us to jump out. I need to jump out to us in the question and kind of get rid of the extra stuff, because some of you mentioned as you're trying to do this is long. This is like almost a paragraph they're having you read, right? So helping with that test taking strategy and being able to kind of read through and see what I can just ignore. So you do have, if you're taking paper tomorrow, you can highlight. You also can do that on the digital platform. If you're taking administration 2 and 3, they'll have a little annotation tool. So in order to go to a certain camp, you need to be at least 13 or in grade 9 or higher, but must not yet be 18. So keep in mind the at least 13 means 13 or bigger, but not 18. So it cannot be like a choice A or C, remember a solid line under the inequality means that you do include it. So I'm looking for one here. So this that does not have a solid line means less than 18, not including 18. Where it has the less than with the equals means it can be, including 18. So that's something that you have to think about. So age is how old are you? Grade is what grade are you in school? Which of the following expressions will be true if the student is able to attend the camp and evaluates to false otherwise? So what I did here to kind of help us before the paragraph where I get to let you choose is kind of highlight those for you. Okay? So I'm kind of walking through this one, and my peer deck is going to be kind of how did you do? How are you feeling? And then we'll do another Boolean where I will actually let you do. So 2 examples here. The first one I'm kind of walking us through. And I kind of already gave little cheaters on this, but for some it's these math symbols that's worse than the Boolean on board. So which one evaluates to true if the student can go to camp and comes to false otherwise? So the first one I said no because it says not yet 18. And the first one included 18. So I need to cross out A and C because they're including 18. Also, this or is highlighted, and C and D, we need to have must not be 18. We need to have an and not in order for these two, for this part. So C and D have to be wrong because these ors need to be and. The first one is wrong because it included 18. So based on my explanation, I already did kind of tell you that B is the correct answer. And now I'm just kind of throwing out here, how'd you do? How are you doing on this? This is a little more helpful on Boolean. And I'm going to quickly jump in and see how your responses are. And then my very next slide is one that you can try on your own for Boolean, just so that you're checking and see how you feel about it. Good. Feeling okay? Still nervous? Yep, absolutely. And I think we still have some definitions, but I'm more relaxed. I took a Comp Sci test there, but it kind of blanked on. That can happen, and it's a practice test, so we're okay with that. Good. And so I like that. Somebody said Boolean are easy, and I also had other people say, no, this is a little tougher, right? Good. I love that. As this 5 hours gets better or comes along, I'm hoping that would be. Now it's seeming easier rather than now it's getting worse, right? Don't understand the first abstraction. We can absolutely jump back to that. Good. Awesome. Good. Let's toss out the next one and see how you do then. That one was easy. Let's do this one. So if I give you n is an integer value, which of the following expressions evaluates to true if and only if n is a 2-digit number? And so I did put 2-digit integer. I did kind of give a little help in the range from 10 to 99, including. That's what I meant by 2 digits. So it's not the number 1 written as 01, right? But here I thought that I was trying to pick a pretty tough one. I'm tossing out mod, I'm tossing out the greater than equal to, the and, the ors, all that kind of stuff. Let's see how you do. Let's see the moment of truth. Let's see how you're doing. Oh, you guys are awesome. Good. So I got a couple of people, right, walking through this that I want to look at that. The correct answer is B, which is the majority. Let's look, because we did have a couple people in each of the others. Which of the following evaluates to true if you have, and only if you have a two-digit number. So as I look at this, n mod 100, 99 mod 100, right? So this is what we're going to be asking about, is it true? But this is n equals. So I'm not even sure that that's a Boolean answer, right? And unless they told us that n is a two-digit integer. So is n equal to that number mod 100? So what they're really saying is n, let's say it's 72, is 72 equal to the remainder when 72 is divided by 100, right? I want to know which one is true. Nope. Next one, B. B does look good to me. So it's saying and, right? So let's just pick any, I use 72, right? And so pick any favorite number between 10 and 99. 72 greater than or equal to 10, true. And is it less than 100? True, because that's what a two-digit integer means. And that's what I was trying to write here, kind of helpful. But if it's bigger than 10 and smaller than 100, it is a two-digit. So B is absolutely true. That makes sense. N is less than 10 is going to be false. And anytime you have a false with an and, it's going to be false. Remember, an and is only true if both of them are true, and that kind of falls out of logic. Right? N is bigger than 10, which is true, and less than 99. Right? In that case, it could be true, but what if the N that you chose was 99? 99 is a two-digit number, but this part would be false. So there is a case where this would be true and false, which would be false. So I would say D would be my best second answer, but there is that one case where if n is 99, this thing would come out as false. Right? So that's kind of my little thoughts or explanations here. B is the correct answer, or the best right answer. The evaluates to true if and only if it's bigger than 10 and strictly less than 100. So between 10 and 99 inclusive. Okay? All right. So my next one is still with me, right? So it gets a little more involved. I am going to, on this Boolean one, it is also multiple choice and pair deck here. This one, I'll give you maybe 20 or 30 seconds to kind of work through. And this was really one of the hardest ones I could find in doing this. So don't panic if it's awful. All right, our results are slowing down a little bit, so I'm going to kind of assume that some people are either still working or just might need me to kind of talk through it a little bit. Either one is fine. I think you can continue to answer there. What I'm doing is bouncing back to the slides so that I can, and again, I think that you can still continue to enter in pair deck, but I want to be able to walk through this, trace through these slides, or the step with you. All right, so looking at this one that some people were still working on, I just kind of want to walk through it. Now I'm getting right, the little tougher ones. And it looked like the majority of people were choosing between B and C, right? So let's look through this. Got some kind of block code given to us. This is like the pseudocode and the tracing through the stuff, right? So consider the following code segment. What is displayed as the result? So we have some logic stuff in here. We've got some Boolean, and we have some storage. So are you tracing through, or what do you want to do? All right. So as we look through, I look at personally, I look at the first three that are my initialization ones. So I just create like my teacher idea sketch here and write in my true false true. Okay. That allows me, my next line says, now I'm going to be kind of looking at, and I wrote a bunch of the little thoughts here, but I have to think about this. This is like my parentheses. Okay? So I have A or B, true or false. So I wrote in here true or false. So it is not true or false. Anytime I have an or, true or false is true. I'm not that, which makes it false, and then I do the and. So when we're talking about order of operations for logical, remember or realize that this is like our parentheses, so the A or B, and we use this in Scratch, for example, right? We're dragging the things. So this is our parentheses. Then the negation of something comes next in priority, and then we do the rest. So for this, I would think I wrote it all out here, but it really took me three thoughts kind of. So my true or false is true. I negate true when I get false, and then combine that with the and. If you have two things with an and, remember they both have to be true in order for that to be true. So false and true is false. Okay? That now is going to be my new value in A. So I took my true, crossed it out, and put my false. Moving on to the next, it then says C and A. C and A is true and false. That is false. That's going to replace my C container. And then I have that where now I have false, false, false. And that's what they're asking me to display or print out. So I end up with false, false, false. Okay. So I know quite a few people, a decent amount of people had C. So just double check. I have a feeling, and I could be wrong, you let me know, but it's either the order of operations with some of this stuff or not knowing. Now, when I teach my kind of conditionals, my ands and my ors, I think about going to an amusement park, right? Whether you are able to go on the kiddie rides or the adult rides, right? Usually, say the difference will be, say, a big roller coaster, right? You have to be a certain age or a certain height, right? And so it's the and or or. Right? Are you a certain age and a certain height? And you can go on the adult ones. If you are not tall enough, they hold that stick up, and if you're not tall enough, you can't go on the adult rides. So think about the ands and the ors for that, okay? All right, we are going to jump in, if you're doing okay still, we are going to jump into conditionals. So I'm going to kind of start here and I will move over to the pair deck again in a second. But have a couple of these because conditionals also can be something that can be confusing. And again, of course, I'm going to toss one out. It's all writing, and then we'll have some tracing as well. So the first one says, in a certain game, you keep track of the maximum and minimum scores gotten so far. If num is the most recent score, which of the following algorithm updates the values of max and min based on timeline ends? I'm going to give you a second to think about that. And meanwhile, I will jump over to my pair deck and see how you're doing. This for my students at least, or when I'm working through and helping with this for some people can almost be as confusing as a swap, right? Because what we're trying to do is we have a score we just got on a game. We need to know, is it going to be replacing the maximum of the minimum score, right? Where are we in the leaderboard, that kind of thing. And the idea that if they were confused on swap, are they also going to be confused on this? Okay. So I'm interested to see. Looks like we're kind of pushing almost to 100 responses here. Let me see what you're thinking. Yeah, we have a forerunner, which is awesome. You guys are doing amazing. So I also agree. As I'm looking at those, I'm going to need to update my minimum if the new number is less than what's in the minimum, and I'm going to have to update my maximum, my leaderboard score, if my new number is bigger than the max. So I agree, it is B. If num is less than the minimum, I gotta swap that out. Otherwise, if num is bigger than the maximum, I gotta swap that out. Okay, good. I have another conditionals one because I thought that first one that we just did was tough because it was all writing and words. I think that the next one can be challenging because it's another trace problem. Right? So after conditionals, then we're going to kind of slide into nested conditionals. Good. And people are finding this one a little easier even. So that's good. So it is nice to see, right? Which ones seem easier to you, whether you are preferring the ones that have the writing out the text or these kind of block, right? The ones that are kind of tracing through. So if they don't give you values, choose values, right? So watch what parameters they give you and use that to choose values that work. In this case, x is 3 and y is 5. So is 3 bigger than 5? So do you know what that sign means, right? Because they're bringing in the math. Math and computer science really interactive with the code that they're doing. So if 3 is bigger than 5, nope, it's not. So this does not happen at all. So if 3 is bigger than 5, which is false, it's going to go down to here and it's going to display 3 minus 5, which is indeed -2. Good job. Looks like majority of people did get that. Okay. So a couple for each of the other choices, but just kind of walking through here. X is 3, Y is 5. I highlighted that in the question to me because that was important. So since 3 is not bigger than 5, it's smaller, I'm going to jump right down to the absolute, which is then going to give the difference of the two, not the sum. All right. So once we get okay with the conditionals, which it definitely seems like the majority of us are, let's go into these, which are kind of nested conditionals. Means conditionals are if. Now we got another if inside that. So that's why they're called nested. So have a couple of these, again, just because they get a little trickier, and I want to be able to make sure that you're good at tracing through it. So consider the following code where integer values x and y. If x is 7 and y is 20, now what happens? Got about a third of you kind of working through that or responding anyway. So just please let us know if you need to reach out if I'm going too fast or need to slow down, please absolutely let me know. Don't wait till that next chat and let me know if we're having issues. But as I'm looking at this, I have x is a value of 7 and y is 20. So when I first start out with this, it says x is bigger than 10, which is not, right? 7 is not bigger than 10. So this whole first thing is going to be ignored or skipped over. So then it says if y is bigger than 3, which is true. Right? Y is bigger than 3. We're going to have 3 or 4. So hopefully you say yes, where x is not bigger than 10. Right? 7 is not bigger than 10, so jump down here. And then it says y is bigger than 3, which it is, so it's going to display the number 3. So my correct answer should be C. Awesome. All right, this next one, I'm going to put the pair doc thing up here, and then before I give you the right answer, this is like another one where I'm just going to kind of trace through it. Because up until now, I've been doing kind of those block ones, but I also want to switch from my block code over to this text code. It's on the right-hand side. This may be a little longer question, so if you need to, run to the bathroom or do anything, feel free. I expect it might take a little longer to get responses into this, but maybe not. Okay, so a little less than half responding, but I want to kind of push through here. It could be somewhere on breaks and just kind of stepped away or whatever, but let's work through this, okay? Score 1 is 350, score 2 is 210. What's the value of result going to be? So we're kind of looking through here, and I'm just going to take a little sneak peek. Okay, so it looks like C is on our leaderboard right now. So let's kind of walk through and see which is correct, by the way. A little sneak peek of the answer. So what I did here, same kind of thing, is I took the choices off just so I could show you my choice in here, okay? So 1 goes in our result, and that is just kind of for our loop here, for the values here, right? So 1 gets stored in the result. If score 1 is bigger than 500, well, score 1 is 350, so that's not true, so I just said, no, my first line is false, right? Therefore, because the first line is false, this whole part gets skipped, right? It's the same. It's just that this is a text-based instead of that block, which some people have a preference one or the other. So it means I'm going to bounce down to the else part, and that's going to run, and then it's going to say result is going to be increased by 5. So what was 1 back at the beginning, now I'm going to have 5 more than that. So 1 plus 5 is 6. Then it says if score 2 is bigger than 500, right? We have up here score 2 is 210, right? So another false. So that's not true either. So now that part's false. So I'm also going to skip another part. And then the only real thing that's happening here is result is going to be changing again. So I'm going to take my answer result, which is 6, and subtract it and decrease it by 1, which is 5. Okay. I thought that was challenging, right? Because sometimes I think it's in our nature to say, oh, they can't all be false, so I must have done something wrong, right? And the score 1 and score 2 in this case are not what's incrementing, they're not changing. It's the result. Okay. Good job on that. So now, kind of moving to another definition that kind of shows here, and this is iteration. And so this question is one of those wordy ones. And you stick with paradox because it's a lot of writing here, but that's where our very first thing is going to be. So I'm going to stop talking for 10 or 20 seconds. Give you a second to read all this. My students hate this kind because they just want one choice. They don't like the choices given like this. So again, shows that. All right. So I'm going to kind of start talking through because it looks like we're slowing down on a little bit of the responses here. But, a few things, like I said, I think that this one is a tough one because there's so much writing, right? And some of us have maybe language barriers, not understanding what some of the words are written. And then you throw in how these choices are, right? 1, 2, 1 and 2, 2 and 3. And that makes it a little more difficult for some people, okay? So what I did is I started out with these, my 1, 2, and 3, and looked and see, like, what do I think about those? Which ones are true? So my very first one, I said number 1 does not work. Okay. So for example, let's go back to this slide first. I'm going to read what's a small paragraph, my 3 lines of text. And then what you'll see is when I go to the next, I just kind of bulleted that. So I'm pulling the things out that are important to me. So whether you highlight those, circle them on a paper test or on the annotation tool on the digital, either one's fine. But I just kind of think what's important because that's 3 lines of writing. So we've got a large group of people in a room, all born in the same year. Not sure I care. Consider the following 3 algorithms that are intended to identify the people in the room who have the earliest birthday based on just the month and day. Okay, so obviously January 1st is the first one. But then if I have January 1 and January 10, I also want to differentiate between those, right? So for example, a person born on February 10th is considered to have an earlier birthday than someone born on March 5th. So February is before March, even acknowledging that 10 is after 5, but February still comes first. So keeping that in mind. Which of the following 3 algorithms will work the right way, the way that we're hoping? So I just want to bullet it. All the people are going to be the same year, so I'm not worried about that. I want the earliest birthday, month, and day. Which of the 3 is going to be the right one? So as I look at this, I said, number 1, if all the people stand up, they find a partner, right? Form pairs where possible, leaving at most one person without a pair. So in case there's an odd number or modulus math again. For each pair, the person with the earlier birthday stays standing up. The other one sits down. If there's a tie, they both sit down. Any individual not part of the pair stays up for the next round. Continue doing this until only one person stands. This person is going to be the earlier birthday. So it says the earlier birthday stands up. That's going to keep happening until the end. But the issue, what if the first 2, it said that if 2 of them had the same, they sit down. If there is a tie, they both sit down. What if the 2 people had the January 1 birthday, but they were tied? They had to sit down. So I said algorithm 1 is not going to work because if we happen to have a tie for the earliest birthday, they both sit down. Okay? So as soon as I find that 1 doesn't work, there goes choices A and C. Next, I work progressively, so I start 1, then 2. Some people will look at the choices first and say, which one could I eliminate best? So because 3 of the choices have 2, maybe I'll check 2 first. It's completely up to you. So next, the algorithm 2 says, all the people stand up. Everyone forms pairs, same as we did before. For each pair, the one with the earlier birthday stands, while the other person sits down. If there's a tie, both stay standing up. Okay, so that seems like a little improvement from the first one. Any individual not part of a pair also stays standing. Continue this until only one person remains, or all persons standing have the same birthday. Anyone still standing has the earliest birthday. Oh, that's the issue, though. Because algorithm 2 allows both people to stay standing when there's a tie, person with the earliest birthday is not going to be eliminated. It's going to continue until they all have the same birthday, which will be the early. I'm sorry. Oh, that's too bad. I put 1 doesn't work and 1 does. I was thinking I did the 2 wrong answers. Okay, so any individual not part stays standing up, continues. Okay, so that one would work okay, right? Because I said it's an improvement on the first one, so that makes sense. If 2 works, I crossed out my 1s. Now that really didn't help me though, so maybe so next I'd look at 3 to decide which one is going to be an issue there. And when I move to the last one, beginning with number 1, ask if anyone was born on that day of the week of the month. That was kind of something I mentioned earlier. Is there an issue? Continue with persons 2, 3, and 4 on until we keep the earliest one. But algorithm 3 is not going to work correctly because February 1 would then be said that it has an earlier birthday than somebody in January 5. So that's something I mentioned earlier, that we have to go on the month and day. So Roman numeral 3 is not going to be correct. So if you got choice B, you did awesome. My next iteration is what they call, some call it a turtle problem. Some call it like a robot problem. These, though, I definitely think that my students do okay with, but I want to make sure that that is always true. So we don't want to mess up any of what some people think are the easier ones. So when we're talking about this, the robot, it says that the following grid has a robot represented as a triangle, initially facing right. If we run a code segment, right, and I did include a text one, but some people think it's a little tougher, I want to move the robot to the gray square. Which of the following can replace the missing statement so that it works the way it's supposed to? Okay. Now, I definitely think that sometimes is the tougher one when you move to the next slide where the choices are. Okay. Now, I'll give you a, some people are pretty quick on that. So let's see how you do. Good. So by the responses, I'm definitely seeing that our leader seems to be B so far, but we definitely have some choices also for the other three choices. So I want to work through this and see, because I do think they're getting a little more involved, right? A little more tricky. So as I look through this, what I did, I have a couple slides here, just same thing, kind of helping us think about what might be right and wrong. So if I start with a repeat one time, if I repeat one time and then it says repeat 4 times, kind of trace through this whole thing, what I'll find out is choice A. So what I did for each of these is say what happened when I traced through each of those and why it wasn't A, C, or D. Right? So my first here is why each one might not work. So we kind of already did say B is the correct answer. So my next slide, I do have like kind of walking through why B does work. But just kind of looking through here, and I think that maybe one of these, if we go through any of the A, C, or D, then kind of like shows you maybe what we do want it to be, right? So if I take any of these, it doesn't make a difference. But if I take something like C, and I say, all right, repeat 3 times, and then go inside and repeat 4 times. I need to move forward 4 times, and then rotate right, right, and turn right, right? So when we look at that, we do that 4 times. So once it turns right, what's going to happen is this one is going to end up being one above the green square, because that's going to happen 4 times, and it's going to rotate left, move forward, rotate right. So once it turns left, remember one thing that I know some people make a mistake with when this robot, when it rotates left, it stays in the same box. It doesn't turn and move. So my very first step is it's going to move forward and rotate right each of these 4 times, right? So move forward, turn right, move forward, turn right, move forward, turn right. And then it's going to turn left, move forward, turn right, or rotate right. And so we need to kind of be aware of that is each time that we rotate, it's not moving, it's just turning in that same box. So the triangle will switch direction by 90 degrees, but it won't move out of that or to the next box. And then what I did is I kind of wrote out why B did work for me. So if I repeat that 2 times, when I go inside here, repeat 2 times, then it says from here, I'm going to move forward and rotate right. Do that 4 times. So the loop that repeats 4 times returns it to the starting position. Then the 3 lines of code that follow the loop move it 1 row up and leave it facing right. Right here. Right? And then when that happens again, so that's my first time, the second time that it happens, it's going to move here. And that may actually even help to finish or to clarify why it wasn't 3 times, because those 3 times going to end up here. Once is just going to end here. Okay? So that one I think was probably a little tougher, right? Next one, and moving off of the text and moving back to our block. So let's move that up and see how you do on that one. All right, moving along. Let's see how you did. A little more scatter on that. Some people thinking A, and so I'm sticking with C. And I would say for this one, what I really want to concentrate on is working through this. Okay? Because when you have iteration and you have like repeated or nested loops, you're really going to want to find a way to trace this for yourself. So C is the correct answer, but what I want to do is kind of look through this and trace this for you. So here's my initialization. Each time I go through this, I'm going to add result plus X. So my X is my counter. So I mean, I'm going to be increasing each time. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10, and so on. So some people, I think, might have got caught on that where they were getting choice A. All right. Next, moving into like the algorithm and pseudocode that we kind of talked about. And let's see. We've got some code over here to the right, text-based code. X and Y are integers. Think about the value of the sum after the loop runs. Now in this one, we want to choose two answers. So there's the code. There's your paradox slide with the choices. Go back for a second because it was a lot for one slide. It got way too small. So what you need to do for this, tell me what the value of sum is when you're done. Once you get sum in your head, X and Y are any integers. So don't choose 58 and 72 maybe. Choose 2 and 3, something small. Okay, so you have the value of sum in your head, as well as what you thought of for X and Y. So my question is now, if I give you 4 choices, at the end of each of the choices is your sum the same as what you find in this slide? Choose 2 answers. And I apologize. I think it looks like I made this multiple choice. Not choosing 2 answers, not the text. That would be easier. So just choose one and then we'll go through and see how you did. And I love this. I think that even as the questions are getting maybe a little more difficult, you guys are still doing outstanding. So even on this slide where it looks like I kind of just wrote where you choose one option, but then I changed the question. I made it so there's 2 answers. And you guys are still getting it. It is true that the correct answers that I have there really would be B and D. So I see that those are the majority kind of flying in here, right? So don't be distracted by my change of that paradox question. You guys are doing well with that. So the correct answers are B and D. And I just kind of, again, you will have access to these slides, like I mentioned to people who were asking earlier. So I just kind of wrote up why B and D are the correct answers. So now we're kind of talking algorithms, but we're also talking about loops that are repeat loops, and they are nested. All right, now we're going to get into some lists, which I know was a question earlier that people were asking, could I explain a little bit more on lists? And absolutely, I knew which the problems were going to be, right? So we're all good. So the next thing I'm talking about is lists. So consider the following code intended to store 10 consecutive even integers starting with 2 into a list called even list. Assume that even list initially starts empty. What can replace the missing code so that it works the way that it should? I'm going to move to the next slide because the next slide gives you your choices. Right? At that point, you can put in what you think and see how you do. Yeah, they're getting a little tougher, right? So looking at this, we're lists, and I know, sometimes it can be a little question here. Looks like we are having the majority of people close between C and D, right? And I completely agree. Those are the two choices I would think. The correct one is C, but I absolutely want to kind of talk through and make sure you're good with this. So for my first iteration, twice of I or 2 is put into the list, and then it's incremented to 2. For the second time, we'll put 4 in and increment to 3, 3 times 2, and so on, right? So that's where the append means add to it, add into the list 2 times each of the first 10 digits. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm putting 2 times each of those into the list each time it runs. So at the bottom, it should be your numbers 2 through 20. Good. So just kind of looking back at here, I think again, between C and D, these look how close they are, right? So my correct answer is C, and the reason really is, excuse me, it says I'm starting at 1. And the difference here is in D, I'm increasing before I'm putting it in there. So because this is already at 1, I want to put 1 times 2 in there before I increase. So that's a tiny difference between C and D, but the explanation why. Binary search. Students tend to mess up on this a little bit, only because binary search has a couple things, and the biggest thing that my students forget is that binary search only can work on an ordered list, and so that's actually my second question. So if we have something that's already sorted, which it has to be in order to be binary searchable, and if it is sorted, sorted means smallest to biggest or biggest to smallest, you have 200 elements in it. Which of the files is closest to the maximum number of list elements that we have to look at to do a binary search for one of the values in the list? So if I am looking at this, what do you think is the most? If I have 200 elements and they are in order from either smallest to biggest or biggest to smallest, if you are looking for, and who knows, that maybe this is the numbers 1 through 200, and you are looking for, it doesn't mean it has to be the number 1 through 200, but they are in there from smallest to greatest or greatest to smallest. You're looking for a certain element. What is the most number of times that you will have to split that list? So I'm really looking as that nobody's choosing C and D. And I do have a couple people, right? And that's what we want to be cautious of. Binary means we're splitting it into 2 lists, right? So I'd absolutely go in with A or B closer. And it usually is kind of cutting this in half each time we do that. Right? So really it's saying how many times can you cut this in half. So binary search starts at the middle of the sorted list, and it can eliminate half of it. So if I'm looking, I got all these numbers in order, and I look at the middle value, decide whether it's too big or too small, and then go that direction for the next. So if I have a list of 200 elements, the list is going to be cut in half to go to 100, and 50, and 25, right? That's what I mean here, those to be cut in half a maximum of 7 times. which then means it should have 8 elements of the exam. So if I look at the list starting at 200, then it's going to reduce down to 100, then 50, then 25 each time that I'm doing it. So that's what I meant by 8 most. Okay. All right, another one, and this kind of, I already told you the answer. I just don't know if you caught it when I said it. So if you have this, but this is a big one because it's saying, why can I not use a binary search? So go ahead and write your response. Let me see if you heard what I was saying. Yay. Perfect. You guys did catch it. That's awesome. So even if you're feeling like, this is so long, stop coughing. Sorry about that. I swallowed some water and made me cough. Sorry about that. Yes, but you're right. Because they're not because they're not even, because they're not in ordered list, I can't use the binary search. So they have to be ordered first. So going from -4 up to 1, but then I went back down to 2, so that I can't do the binary search. Good. And that's what I wrote. Binary search can't be used for this because it's not sorted. And that is something that we will absolute tests. I seem to see that come up quite a bit. Next, I am talking about calling procedures. We are doing good on this huge big idea 3. Remember, if I am going a little too fast, you can always go back and look at the slides of the recording or the decks later. But what I want to talk about is, again, tracing through this. I have the following procedure. What is displayed when this happens? Running rock birthday to you. So consider this. What is going to happen? This is calling procedures, and the next one we're going to do is developing procedures. So a little bit of procedures in here. And a little slower on this, which absolutely, our procedures can be a little tougher. I'm going to see what you're thinking. Good. D is the right answer. So even though you're kind of taking a little longer, moving slow through it, seems like we're still getting it. So looking there, what I have here is my first call as I'm looking through this. My call for the procedure 2 is going to assign birthday to string 1 and to you to string 2. Right, so I got that. As we're looking right here, as it says my procedures, here's string 1, string 2. So when I call to procedure 2, I'm putting birthday in string 1 and to you in string 2. First statement in procedure 2 calls procedure 1 and assigns to you. So that's where it gets a little confusing, right? So we got this, but then it's going to call procedure 1 with my string 2. We just got done saying that string 2 is to you. So that's going to go up here. So that's how it kind of got backwards. Instead of birthday to you when I put here, my to you gets thrown up here. Okay, so it'll display to you, and then it'll display happy. Okay? So that's what we're talking about. And then procedure 2, we have the birthday here. We're going to display. So we're going to start here. We're going to go up here and then finish with the birthday. So that was definitely a little more confusing. Now when we're talking about developing procedures, just going to go through the definition. The first one, I think the second one is decent too. I have a couple examples here because it gets a little more confusing. So a student is developing a program that looks for the definition of words that appear in a book, Student plans to perform a large number of searches through a dictionary containing words and their definitions. Right? Let me give you a second. You read through that, and let's see how you do on it. There we go. Coming in a little bit quicker now. Yes. You guys are doing good. Okay. So what we're looking at here, I absolutely agree. C is the forerunner, and just kind of writing here that student knows the procedure searches for a value without knowing how it does the searching. So this is actually called procedural abstraction. Okay. So good. That I thought was a tough one because it pulls out some really random definition stuff, right? So some deeper thinking for that for sure. This also I thought was a little tougher, which is not a benefit. And I find that students sometimes when it says which is not a benefit, sometimes they miss that not. So student completes, I'm trying to think, I actually think this one I just didn't make because I just knew it was going to be a little quicker for that. We complete a program and ask somebody for feedback. So this brings in our collaboration. So for Big Idea 1, suggest rewriting some of the code to include more procedural abstraction, which is not a benefit of procedural abstraction, right? So the idea that making the code run faster is not necessarily a benefit of the abstraction, okay? So modularity and code reuse not really necessarily going to mean it runs faster. All right. So now kind of pulling in, we are doing awesome, moving along, talking about libraries. Anybody need a break? Everybody doing okay? Good. We're going to, libraries is all right. That's like the end of our definition stuff. And then we'll talk a little bit about some random number values, that kind of thing. Almost done with Big Idea 3. And I'm going to try and squeeze in some Big Idea 4. And then Miss Troy will come in for 5. So this kind of thing, you guys are doing awesome. You guys do this without me. Let's see how you're doing. Doing good. Sweet. So we got a data file with 10,000 values. We're writing a program to compute the average of them. Which of the following procedures is most likely going to be useful? Yeah, I really think you're doing awesome on this. I am going to lean towards C because it's the sum that's going to take the most time, right? The quotient when we divide one by another, that's going to take forever, right? So I absolutely would say C is going to be the best. The sum is what's going to take the longest. And once we get that sum, then we could just divide it by something. Very good. All right. Now jumping into random values. I just really have like one of each of the rest from Big Idea 3. So random values, which of the following cannot be displayed when as a result of this code? 1 starts out in I. Repeat until I is bigger than 4. We're going to choose a random number between 1 and I. So the first time, that's it. It's between 1 and 1, right? And it's going to display that. So all of those do that. So it's not really super helpful. And then now once we increase this, right, now we're up to 2. So now we need a random number between 1 and 2. Let's see how you do. Good. Nice. Okay. So same kind of thing. As we're looking, we get up to 2. We're going to have a random number that's going to be between 1 and 2. So it could be 1 or 2. They're saying which is not possible. So D is not possible, right? Because the very second step says in the second iteration, I is going to be 2. So the random is going to be between 1 or 2. So when it then is going to repeat or display that random, it's either going to display 1 or 2. It can't display a 3. Good job. Next, we're talking simulations. I'll give you 5 seconds to kind of read through this one and then put up why I think what answers are wrong. And then we're going to shift into a little tougher definition. Good. Remember simulation, I'm just going to kind of talk as you're doing this. Simulation is stuff that might not be economical or safe. So I am going to do a simulation when I'm talking about plane flight out of an airport or into an airport. I'm not going to send $1 million planes and risk lives if they're going to crash, right? So we're using simulation software to study crowd flow at a big arena after an event ended. The arena is located in a city. Which of the following best describes the limitation of using a simulation for this? Let's check out a few. And nice job. So it's between B and D, it looks like. So my first slide, I'm going to tell you why I don't think it was D. So I'm glad, like people were saying, they didn't lean towards A or C. But looking at D, running a simulation requires a larger number of observations to be collected. Well, in order to validate the results of a simulation, you might need observed data, but running a simulation doesn't require observations before you can use it. So that was kind of a little nuance there, a little fine line between that. But because of that, simulations are limited by the model that's used, though there might be reasons for a simplified model. Looking at the next line, here is a definition. Definition of a heuristic. Heuristic is a technique to solve a problem more quickly when classic methods are too slow. Or finding an approximate solution when we really can't find an exact solution in other ways. Right? So a little definition there to help you with the next question. Which of the following solutions is best to use a heuristic in order to find a solution in a reasonable amount of time? You guys are doing good. B looks like the right answer. Absolutely fine. since this algorithm has a factorial efficiency, it's not going to run in a reasonable amount of time. So heuristic can find an approximate solution. Okay. Now that brings us to our undecidable,s right? So we have something that's considered undecidable is any instant that we just can't get an answer to work for it. And that is cases that they will talk about on the test. So look at that, which is an undecidable. Which of the following explains how algorithms that run on a computer can be used to solve problems? Let's see how we're doing. Good job. Undecidable problems cannot be solved with an algorithm. Absolutely true. Okay, good. All right. So next, how you doing? That was big idea 3. Tired, yeah. All right, here is 6. Okay. Started messing up, and some of that is because it's been 4 hours now, right? Good. Yep. Yes. Yep. Absolutely. Why don't we? Why don't we take a break right now? And while you guys are on a little break, I'm going to kind of swap over with Miss Choi. Okay. She is going to do, because we're at 5:24. Let's take a break, and we'll say that we'll probably do till 25 after or 6:30 Eastern time. And she can then do the big idea 4 and 5. How's that? Awesome. Yep. I'm just going to check this. Good, good. Yes, go take a break. I'm just reading the chat. I'm reading the comments. I'm going to switch over, okay? You guys are going to kick butt tomorrow.
Welcome. So let me go ahead and start by sharing my screen with you. We're going. There you go. Okay, so I see that chat has been disabled, but I'm just going to enable it for a second, just because when I'm taking over, I need to give you a new link to Pear Deck. I hope you don't mind that. So just go into the chat really quickly, just to click on that. All right, good. I see that you guys are joining this session right here. So we'll start with big idea 4 over here. It is called Computer Systems and Networks, and it will be 11 to 15%. All right, so let's continue on over here. Current topics in Big Idea 4, the internet, fault tolerance, parallel and distributed computing. So before I even continue on, I just wanted to let you know that with Big Idea 4 and Big Idea 5, suddenly computer science is not even about coding anymore, right? So this is now kind of like a social studies class where truly, if you choose to read all the things that you're supposed to learn, that would definitely prepare you for the actual test. And so what do I mean when I say that? I'll go ahead and explain to you in a bit, okay? So for now, let's continue on over here, okay? All right, so here is our simple question. I'm going to go into the slide deck and take you to slide 141. That is a long ways down. There you go. I'm going to try and make this easier for you to read. There you go. All right, so let's go ahead and take a look at this question over here. Which of the following best explains how messages are typically transmitted over the internet? I'll give you a minute. Let's go ahead and put in your answer. All right, so let's take a look at how many of you have responses for me. 48 responses, 50. All right, let me just go ahead and wait a little bit longer. Alrighty, let's take a look at your responses. All right, so most of you have answered B, right? All right, so let's take a look at the answer. Yes, the correct answer is B. The message is broken into packets. The packets can be received in any order and still be reassembled by the recipient's device. So just remember that when we send a message through the internet, messages are broken into little packets, and each packet contains data to be transmitted as well as metadata. And in case you forgot, metadata means data about the data, right? All right. And once those packets reach the other destination, then it gets reassembled. So it's all in order. And then, it's sent to the receiving person, okay, or the receiving computer. All right. Here's the next question. This is slide 143. So let's go to slide 143. There you go. Which of the following best describes the relationship between the World Wide Web and the internet? All right, let's take a look at your responses. All righty, let's take a look at your answers now. All right, most of you said C. Let's see if C is the correct answer. There you go, it was correct. The World Wide Web is a system of linked pages, programs, and files that is accessed via a network called the internet. Good job. All right, so let's move on to the next question. As you can see, we're kind of like hurrying to solve as many problems as possible because it's just a matter of remembering what we learned in class, right? Just refreshing our memory. Let's go. All righty. I'll wait a little bit longer. All right, let me hop onto the other screen to look at your responses. Oh, you guys are still responding, so I'll wait a little bit longer. All right, let's take a look at your answers. Most of you said A. So let's hop on over and see what our answer is. There you go. Good job. So remember, fault tolerance means we have more than one pathway, because if something happens, like if a mouse came and ate up the wires, because yes, the internet, you think that it's not connected and it goes through the air and all that, but actually they do go through fiber optic cables, right? And so if they get disconnected, then we'll have a different route to go to. So awesome. Let's move on. Fault tolerance in a network can be achieved by, see, that was the question that you just looked at, right? Providing multiple paths between devices. So if a mouse eats up a fiber optic cable, it's okay. We have another pathway. Enabling routing to occur even in the presence of a failed component. When a system can support failures and still continue to function, it is considered fault tolerant. Vocabulary words are really important, right? So don't forget this one. If you are taking notes, right now is a good time for you to write down this highlighted vocabulary word. Redundant routing within a network allows it to support failures and still continue to function. Yes, awesome. Let's continue on. The internet is considered fault-tolerant system because there are multiple paths, right? Redundant routing, allowing messages to be sent even when part of the network fails. Messages can be transmitted even in the presence of network failures. All right, so primary benefit of making a computing system fault-tolerant is that if one component of the system fails, user can still access it, right? Otherwise, we'll have problems if we cannot access the internet because one little portion of it broke down. All right, so now I'm going to go ahead and give you a minute just to read this. Okay, so we have 3 different kinds of computing systems. Just read. Okay, so that at this point, you should know that sequential computing means we have just one computer and things are happening from the beginning to the end. That's it. in order. Parallel computing is when there's just so many data, so much things to do. And so we're going to go ahead and divide it up in between maybe 2 or 3 computers. And they're all working the same thing at the same time, but of course not the exact same task, right? So we're going to do different things, but all at the same time, right? Distributed computing means there are many, many devices, like all of us using our own devices, okay, to solve a problem or do something. Okay. Sequential solution obviously takes as long as the sum of all of the steps. Parallel solution is probably going to take a little bit shorter because you would still have to go through the sequential tasks. But then there's this other portion where multiple computers are dividing up tasks and doing them at the same time. So if 3 computers or are working on the same thing, then the one computer that takes the longest, well, that's the time that we'll have to add to the sequential tasks, right? And then the third one, parallel and distributed computing leverage multiple computers to more quickly solve complex problems or process large data sets. Distributed computing is the best way to solve problems where we need data from everywhere. All right, distributed computing, each processor has its own private memory. Parallel computing, all processors have access to a shared memory to exchange information between processors. All right, so let's move on to slide 153. There you go. Let me give you a minute. All right, guys, so let's take a look to see what you have for your responses. I see 43 responses and counting, so I'll give you a little bit more time. All right, so now let's take a look at your responses. Oh, most of you said B. Let's take a look. Okay, B is 30 seconds. Yes, the correct answer is B. So running the 2 processes, one after the other on a single processor requires 30 plus 45, which is 75 seconds, right? Because we have to do both of them. But if we run them in parallel, then it only requires 45 seconds because they start doing the process at the same time, and process P will be completed in 30 seconds, and we'll just be waiting while we wait for the other processor Q, right? Processor to finish Q, which is 45 seconds, right? Okay. So therefore, the amount of time saved by running the 2 processes in parallel is, so remember when you add them together, is 75 seconds. And then you got to go ahead and subtract the 45 because if they run it parallelly, that would be how long it would take. So that is 30 seconds, right? Okay, awesome. Let's move on. Yes, how are you feeling so far? We got to go through that. Yes, there you go. Any questions, thoughts, comments? You can go ahead and type your comments really quick and then go get a glass of water. So I'm going to read through it. So you know, I love the yay, yay, yay. So if you have a yay, 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 because you're getting everything in this section of the CSV test is easy for you, just go ahead and give me a yay, yay, yay. Alrighty, if you are done typing your responses, go ahead and take a water break for like 2 minutes. I think that's how long it would take for me to read everything. Bueno! Checked out. Ooh, okay. Hey, guess what? If this is your weakest section, you have no problems. Today, just read through this link that I'm going to give you soon, and then you're going to be okay. Okay, awesome. All right, you're feeling good, overwhelmed, good. Yes, yes, for us. I am not even in the CRAM. Oop, what does that mean? Uh-oh, I'm getting rough? No. I'm nervous as always. Okay, awesome, awesome. You're such a great teacher. Yay, yay, yay. After the switch over, yay, yay. No, it's because the topic is easy. Yay, yay, yay. Feeling good. Do we have to know the difference between TCP and UDP? Yes, you do. If you don't, we'll have a problem. And if you want to know what the difference is, you know we have our favorite TA, Rachel Yun, right? I hope I said her last name correctly. Or Juan. Uh-oh. She's going to correct me soon, right? Okay, all right. Oh, I thought that was it. I felt a little unsure about parallel computing, but the last one really helped. Yes, parallel computing is not that difficult. Yeah, it's just two processors working at the same time. What's the difference between parallel and distributed? Oh, parallel means two processors are working at the same time. They might be doing different things, right? So we can finish the same task faster. Distributed computing is, and you're going to talk about that in this next big idea, where you have all these different devices. So say, for example, it's like crowdsourcing. So I'm not going to talk about it right now because we're going to talk about it anyway. Okay, so stay tuned. Let's see. Oh, okay, yeah, all this vocabulary and all that, you know, it's not that difficult. Just write it all down in your notebook and then kind of skim through it, remind yourself what the terms are, and it will come to you. Can you talk about the memory needed for parallel versus distributed versus sequential? All right, so let's just talk about parallel and sequential. Sequential means you have one processor, so you have to start from step 1 to step 100. Let's say I have 100 lines of code. Well, with sequential computing, you got to go from step 1 to all the way to 100. That's it, 100 steps. Now, if I have parallel computing, right, then I could divide it up into like maybe 40 and 60 different instructions, right? So instead of having one processor go through step 1 through 100, I'm going to give one processor 40 steps and then the other processor 60 steps, right? So it's obviously going to take a shorter period of time for parallel computing to finish any kind of task. We good? Okay, yeah. The biggest thing about taking the test is you got to read the questions carefully. And that's something that teachers do a lot. Teachers have been teaching forever, guys, ever. And when we try and solve problems, we always make mistakes. You know why? Because we think we know everything, and so we don't read the questions carefully. So please pay attention to the words like not, or like difference in time, or the best, or the least, or nots. Okay? All right. Dead brain cells trying to act cool. Yep, that's how I feel sometimes. Feeling good. Yay! My brain is in pain, but I'm holding on. This is pretty easy so far. Yay, yay, yay. I'm tired too. Good. I'm confident too. Procedural assertions from Big Idea 3. Oh, no. Okay, we have to move on, okay? Yes, we have to move on, and we're going to depend on Rachel, okay? So you lean on Rachel. Little confused, but I would play it one more time. Replay is the best way to go, all right? The difference between parallel and distributed computing. Yes. Okay. Oh, yeah. I love your energy too. Okay. Is parallel computing more than one computer or more than one processor? It could be more than one computer because, you know, a computer could have only one processor, right? I mean, you know, the old ones. But these days you have more than one processor, right? Yes? No? Yeah. So it all depends. It could be more than one computer. It could be one computer with more than one processor because, there are different kinds of computers, right? Yes. PEMDAS. PEMDAS is important. Okay. Yeah. Oh, no, I can't read everything, but I'm going to go ahead and. Oh, okay. So this one, you know what? I'm going to go back to that question because you guys are really, really. Thanks for not coughing. Okay, I'm going to stop reading all that. You guys are too amazing and telling me too many things. Okay, I have to go back here because you're asking me too many questions here. Okay, we have a computer with 2 processors. Okay, so this is one computer with 2 processors. You know that we have computers with 4 processors, right? Quads. Okay, anyways, the table below indicates the amount of time it takes each processor to execute each of 2 processes. Okay, so process P means like the steps, whatever code it has to follow. Okay, so we need to do 2 things, P and Q, all right? And then this is what it takes. Let's say we have one processor. We're going to call this processor 1. And processor 1 is going to take 30 seconds to complete P. And then processor 2 is going to take 45 seconds to complete Q. Now, of course, if we go through a sequential process, right, then we have to do process P and then Q, obviously, because we only have one processor, right? So then we're going to have to go 30 plus 45 seconds. So it would take a total of 75 seconds, right? Okay, but then it says, which best approximates the difference in execution time between what? Running the 2 processes in parallel. So that's one option. We're going to do P and Q, but we're going to use parallel computing. Versus instead of running them one after the other on a single processor. So if we only had a single processor, then we got to do P and then we got to do Q. So it's going to take 75 seconds, right? But then if we have parallel computing, then P is going to take 30 seconds for processor 1 and Q is going to take 45 seconds for processor 2. So let's say we started the timer right now and 1, 2, 3, 4, 5, 6, blah, blah, blah. Now we're at 30 seconds. Processor 1 is done, but is processor Q done? No. So we are not done with P and Q yet, right? So we got to wait for processor 2. We got to wait 15 more seconds for processor Q to finish doing its work. So in the end, if we use parallel computing, it took us 45 seconds to complete the task, the process P and Q. Right? So all we have to do is go 75 minus 45 because we need to know the difference in execution time. The difference means subtract, right? That's why it's 30 seconds. All right. So I better get more yays after I do another check on you after Big Idea 5. Okay. So I'm going to have to move on. If you guys are still writing comments, I'm sorry, but I can't read. All right, Big Idea 5, impact of computing, 21 to 26% of your test. Dun, dun, dun. But again, it's not going to be a big deal, trust me. All right, here are the 5 big ideas: beneficial and harmful effects, digital divide, computing bias, crowdsourcing, legal and ethical concerns, and safe computing. All right, so here are the 5 things that we have to look at. Please let me know if I'm going too fast. Well, you can't let me know, but if you let Rachel know, she will let me know. But be nice, because I'm nice to you, I think. All right, let's see. So there was a lot of students asking about distributed computing, right? So I just want you to think about this word here, crowdsourcing. It's kind of like the same thing, okay? All right. All right, so right away, I'm going to give you a question. Let me take you to slide 160. There you go. Let's solve this problem. This is not multiple choice, obviously, right? So you have to think about it and type it in. M Preventer. That's a cool name, huh? I made it up. It's a crowdsourcing app that allows people to place different items such as spices or soap water where they spot ants to create a barrier and report whether the placed item deterred the ants from passing the barrier after a few hours. The app stores the location of the spotted ants, the items that was placed to create a barrier, and the result after a few hours. What are some data privacy concerns for Ant Preventer users? So you gotta think, I am using Ant Preventer. What am I worried about in terms of my data privacy? Okay, I'm gonna stop talking. Go ahead and give me your answers. Alrighty, let's check this out. I'm going to show responses. The location of users might be able to be found after multiple geographical inputs in an area. Yeah, could reveal users' location. Can you imagine, like I said where I am because this is where the ants are, and then I have to come back a few hours later. So somebody could be like, ooh, I wonder who this user is. Her name is pretty cool. Her name is Princess. Maybe I want to go check that location out and see who she is. Ooh, that's very scary. All right. They are putting the barriers and stuff near their own house or inside their house so the app knows where they live. Oh, that's a very good one, huh? Storing location. Yep, location. Ooh, scary. If someone hacks the app, then they can get the users. They don't even have to hack the app because, it's right there. Geolocation and Preventer can see where the items were used. If it stores the locations of the spotted ants and the user spotted the ants in their home, which is where most people usually spot ants, yep, where their houses would be stored. It can give away their location. Yeah, I mean, most of you got it. Awesome. Bright group here. Address, yes. Oh, yeah. All right, you guys are all correct. So let's move on. So then the next question says, it's the same app, okay? What would be a benefit, though, to users of the application this time? This time we're thinking about benefit. All right, guys, let's check it out. 53 responses. This time I'm going to try and start go like towards the middle or something. Okay, there you go. Learning how to prevent ants with others' input. Users who are having trouble with ants can see what worked for others. Yes. They can see what remedies generally work to get rid of ants. Yeah, and the keyword was natural, like spices, soap, no chemicals, right? Help others on ways to create a barrier for their ants. Users can learn which methods work best. And yeah, because a lot of people are using this app, right? You can see many different things, right? People know to stay away from nasty people that have ants. Oh, okay, I don't know. But that's a good one, okay. The app can give data on the most effective way to stop ants. They can figure out a way to deter ants from their house, controlling the ants. You can find out what deters ants from where you are, like your pantry or something. Yes. Finding out what deterred the ants from passing the barrier after a few hours. You guys are awesome. Okay, I'm going to go back to my slide. Let's move on. That is awesome. Yes, that is a benefit. And that's the whole purpose of this app, right? Okay, same thing, kind of similar. All right. So here's the thing, guys, about digital divide, right? I want you to read this first by yourself and then kind of think about, okay, what is a digital divide? So big idea 4 and 5 is mostly about just, things that you could read and it's just common sense, right? So you understand it. So the only difference is you have to know the key terms. So that way, when you hear the word digital divide, you need to understand what it means. You already understand the concepts. You did not know that those concepts were connected to this word digital divide. So that's the only thing you have to do, okay? So let me give you a minute to just read. All right. So if while you were reading this, you were thinking, oh my goodness, inequality, no access, unfairness, anything like that, then you're good. So this is the truth. Internet access is not really a thing for everybody in the world, right? All right. So we're going to move on because I know you read. So here's your question that you have to answer. Let me give you a minute. Read the question carefully. It says, which of the following activities has the greatest potential to contribute to the digital divide? And we just read the definition of the digital divide. All right, I'm going to go take a look at your answers. Let me see. 57 responses. I'll wait a little bit longer. All right, let's take a look. Ooh, so, that's like an even divide between A and D, right? Because A and D are absolutely correct. Like both of them are very close to the answer, right? But if you had to pick between A and D, what would be the best one, the greatest? So, both A and D have potential to contribute to the digital divide. But which out of the two do you think has the greatest potential? So, these are tricky words, greatest. So if a student has to sign up online to speak to a counselor to take AP classes, does that contribute more to the digital divide, knowing what digital divide means? Or signing up online to take classes on how to use online programs would contribute more to the digital divide, right? Think about it. Did we have people changing their minds? Yes, guys. Okay, the greatest potential would be D, right? Because, all right, if you have to sign up online to speak to a counselor to take AP classes, that is contributing to the digital divide. The students who do not have access, to maybe internet or they don't know how to use, internet platforms, they might not be able to take AP classes because the only way they can talk to a counselor is through online, right? By signing up online. So if they don't know it, they're not going to get the AP classes. But look at D. This is even worse because look, you got to sign up online to take classes on how to use online programs that is offered by the school. Now this child, okay, you don't even know how to go online, you don't have access, and you don't know how to use anything online. But it's even worse because this lesson that you have to sign up for is going to teach you how to use all the online programs offered by the school. Now you're really, 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 going to be in the darkness, and that is not okay. All right, so I hope that helped you. Always read the question carefully. Greatest potential. So let's move on. Next question. Which of the following actions are likely to be helpful in reducing the digital divide? This time you have to select two answers, okay? Two answers. This time it's not most likely, it just says are likely. All right, let's see what you posted. 57 responses. Are we still going up? Okay, maybe I'll give you like 30 more seconds, okay? You have to select 2 answers. These are really key things, right? You have to pay attention to things like select 2 answers. And this time it says, which of the following actions are likely? It doesn't say most likely. So it's not like you got to pick one answer. Whatever is likely, and you're going to select 2 answers. All right, so now let me check your answers. All right, so a lot of you said B and C, A and C, B and C, B, C, B, C, B, C, B, C. Let's see. Okay, so yes. If you're regulating citizens' access to websites, that's what's happening in China, right? That's not cool because then we won't be able to get information that everybody else in the world is getting. And then D, allowing members with monthly premiums to access different tiers of websites. Really? So what if I want to get information on how to prevent cancer and I can't get that because I need to pay a monthly premium for that? Well, then are you telling me that all the people with no money are not going to be able to prevent, themselves from getting cancer? That is so unfair. This is like a humane issue, right? Anyway, so yes, the answer is B and C. Okay, so hey, you're homeless. I know you don't have money, but I'm going to go ahead and give you. The government is going to, well, the government is all of us. You know that, right? So we're going to give you free cell phones because we don't want you to be so far behind that you'll never, go back to being self-sufficient again, right? Okay, and then providing training for seniors, right? Because like my mom, she doesn't know how to use a cell phone, right? Well, she does now because I helped her, right? So this is really important. All right, let's move on. What are some ways to reduce the digital divide? You should already know by now, but let's go ahead and type that out. What are some ways to reduce the digital divide? All right, let's see what you got. 54 responses. Maybe I'll wait a little bit longer. All righty, let's start looking at your responses. Yes, provide training is really important, hopefully for free too, right? Not charging people for that. Wi-Fi access, yeah, wouldn't free Wi-Fi be awesome? Yes, awesome. And are you trying to tell me your name? A? Okay, awesome. Okay, give laptops to students in school. Give free cell phones. Put all government forms on paper. Yeah, everything is online these days, huh? Provide technology for students who do not have any portal hotspots. Yes, like a bus with a Wi-Fi router. I think that's awesome. And I see you're still writing. Provide greater access to internet connection, lessons, and libraries for those with economic disadvantages. Awesome. Provide training for I'm waiting technology. Yes, very good. Keep your ideas flowing. Having government provided phones for those unable to afford it. Teaching someone in your personal life about new technology. That's so important. Help people around you. Give poor people free Wi-Fi and free devices. Allow libraries to give computer access for free. Supply people with internet access. Yeah, most of you are saying the same thing, right? So free information is kind of important. Internet in places where there's less access. Very good, guys. Very good. Have ISPs bring internet access to rural areas. That's very important. I went to a rural area and everybody knows each other because, in a whole school, there's like 80 students and that's really awesome. But some students, they focus on other things in those areas because they, don't know. Yes, good job, you guys. Educating and providing access. Those are like the main things, right? To bridge the gap with the digital divide. Yes. Yes, it is unrealistic. Yes, we're not, we're just, talking about ideas, right? Okay, so I'm going to stop looking at your responses. I think you got the idea. Let's move on. Oh no, what have I done? Okay, no, never mind. No worries, I'm good. All right, next slide. More questions, guys. You see how I'm throwing questions at you like boom, boom, boom? And then you're supposed to be like, yay, yay, yay. Okay, let's do this. All right, so in case you didn't notice, we are no longer talking about the digital divide. We're talking about bias. It says least likely, least. Let's see how many of you responded. 33. Let me wait a little bit longer. There's only one response. The question says least, right? So maybe there is more than one good answer, but we're picking the one that is least likely to introduce bias. Alrighty, let's take a look at your answers. Okay, so most of you answered B. Yes. Okay, so just remember with a question like this, there's always bias in anything. So whenever you do like a random sample, that's like the best way to do things, right? Because think about it. If you're enticing users to spend more time by providing the new feature to players who play more than 5 hours a day, there is bias in there, right? We're only providing services to users who are already playing a lot, right? And then for C, only players who are at experience levels, isn't that the same as A, right? Okay, and then the last one, providing the feature only to friends of the developer, really? So then that's really, really biased because maybe all your friends like lived in the same neighborhood, like the same kind of food because, they're your friends, right? And so you would definitely not get a good sense of what needs to be fixed in terms of bugs, right? Okay, let's move on. So please spend a minute reading this, computing bias. So listen, guys, computers do not have bias, but then the people who program things have biases, right? And so that's why we have to actively always think. We should always think to figure out, if there is bias in my algorithm that I created, okay? Because when we get into this field of computer science, we're trying to make the world a better place, right? If you're not, if you're trying to make this world a worse place, please don't go into computer science. All right, but even though we have good intentions, sometimes bad things happen. And even though we mean good for everyone, sometimes there is bias. And so some people end up not being treated fairly. And that's not okay. So then here's the next question. Same question about M preventer. But this time it says, which of the following best explains why such an approach is considered useful for this project? All right, let's go ahead and see what you said for your answers. Only 27 responses. I'll wait a little bit longer. right, guys, so let's take a look at your answers. Let me hop over there. 81 responses. Okay, some A's, but mostly C's. Let's take a look. Yes, okay, so which of the following best explains why such an approach is considered useful? The answer is C. Oh, wow, I gave an option for D. I wonder why I did that. There was no D in this question. So the 6 of you, okay, thank you for participating, but there was only A, B, and C. But the correct answer is C, because it's true. Distributed individuals are not more accurate, because this is just random people providing information, right? But this is also not something that require somebody with a lot of knowledge about ants or anything like that, right? So B, the scientists do not have time to try different barriers. That is not true. The scientists really, yeah, they're always busy, but it's not that they do not have time to try different things. It's just that the correct answer is C. This is the best answer, which is you can collect more information much faster than the research team. If the research team had 5 people versus, let's say, 1,000 people are using this app, you'll be able to get information way faster. And so, guys, some of you, when you were saying, hey, distributed computing, how does that work? It's kind of like this one, a crowdsourcing app, like all these different computers, all these different devices doing something to produce a result, right? So when it comes to distributed computing, you cannot talk about a time, because it really all depends on how many devices are working together, right? So that kind of ties into big idea 4. For those of you who had that question, I just wanted you to know that I answered that question right now. Let's move on. Next question. All righty, let's see if you have your responses. 17, I'll wait a little bit longer. Alrighty, let's take a look at your answers now. 68 responses. Okay, so most of you said D. When a parent takes a picture of the child's homework and posts it on a website, anyone who knows how to solve the problem responds and explains how to solve the problem. You guys are so amazing. Yes, D is correct. So if you look at options A, B, and C, this is really a great way to help the parents during the pandemic who want to help teach their children at home, right? Having a website is really cool, but this is just the website doing the work. With B, when a parent takes a picture of the child's homework and the app gives the answer along with explanations, okay, that's very nice, but it's just the app working by itself. Kind of like there's an app for math, photo math, right? And then C, when a student is struggling, an app pings the child's teacher and sets up. So again, this is what the app is doing. D is the only one that uses crowdsourcing. Crowdsourcing is using distributed computing, right? We have all these people available who are just sitting at home wanting to make this world a better place, and a parent who's frustrated but don't know the answer to this computer science question takes a picture of the child's homework and posts it on a website. And Miss Choi is sitting here going, oh my goodness, this poor parent, let me go ahead and respond to her so she can help her poor child, right? So this is crowdsourcing. Anybody in the world who has the answer can help this poor parent out and the child. Okay? All right. Good job, you guys. Let's move on. Next question. Boom, boom, boom. Questions. So crowdsourcing is the practice of obtaining input or information from a large number of people via the internet. Duh, we just figured that out as we were solving the problems. Science has been affected by using distributed and citizen science to solve scientific problems, like the End Preventer app, right? So citizen science is scientific research conducted in whole or part by distributed individuals, many of whom may not be scientists, who contribute relevant data to research using their own computing devices. Okay, so now tell me, what are some benefits of crowdsourcing? All right, so, guys, let me hop onto the other side to look at your responses. 62 already. You guys are quick. All right, potential for massive amounts of data. Yes, that's really awesome because, we can get data from everywhere, everyone. Reduce bias. Yes, because it's not like you're right. It's not like you have to pay to upload anything. Everybody's just helping out, right? That's the whole point. You get more perspectives. Yes, that is always important whenever, you don't want to just, maybe you and your friends think like wearing straw hats is like the most fashionable thing in the world. But you know what? You need to get more perspectives, right? You need to crowdsource some information. So when you go outside with your beautiful straw hats, you understand why other people are giggling at you, right? When you're trying to go to like a conference wearing straw hats, right? Yes. Okay, helps connect people with each other and be able to help each other by giving examples versus just Googling, getting a straight up answer. It's more descriptive. Good job. Perspectives, better solutions, gathering info at a faster rate. That's very important. Yes, yes. Yeah, kind of like when you go into Facebook and you say something like, I need to take my mom to a really great restaurant, but I know it's too late. Where would be really good? Because I don't want my mom to be angry at me. And, you get all these kinds of information that you never really thought about because people are all, willing to help. Good job. Yeah, reducing bias is one of them, right? Because, but it really all depends. The bias thing is a very, very big animal. All right, yes, diverse perspectives, more efficient. Yay, yay, yay is my favorite answer. Okay, guys, let's continue on. Good job, you guys. I think you got it. Next one. So, wait a minute. Did I not make this into a question? Did not. I'm sorry, guys. Okay. So, anyway, you wrote a beautiful novel for your language arts teacher because you guys are AP students, and that means you guys are awesome. It took you the whole semester. You must have been like really into writing this beautiful novel. And then a few years later, you learned that your teacher published a short novel, and it was the one you wrote. Oh my goodness. Oh my goodness. How do you feel about this situation? Too bad you can't talk about it right now, but think about this. How do you feel about this, right? Oh, by the way, your teacher is making money, right? Because she published it. It was the one you wrote, but she said she wrote it. Oh no. All right, so let's go ahead and read this as you feel your anger, okay? Just read this. Remember, material created on a computer is the intellectual property of the creator or an organization. Okay. Ease of access and distribution of digitized information raises intellectual property concerns regarding ownership, value, and use. Measures should be taken to safeguard intellectual property, and the use of material created by someone else without permission and presented as one's own is plagiarism. Plagiarism, and may have legal consequences. Mostly they do have legal consequences. They get sued, right? You should sue your teacher. All right. The use of material created by someone other than you should always be cited. She should have at least said that you wrote it, right? As with any technology or medium, using computing to harm individuals or groups of people raises legal and ethical concerns. Okay, so then there's like so many things that I'm writing here. It's just stuff that you have to read because these are things that you have to know. It's like common sense, but also these are things that's going to show up on the test. So here are some examples of legal ways to use materials created by someone else, which is like if your teacher wanted to use your novel and publish it, you could have, maybe, oh, not her, but if you went through Creative Commons, right, and said it's okay for anybody to use my novel and make money off of it or even modify it, then your teacher could do that and you cannot be angry because you said it's okay, right? But if you never did that, then legally it's still your own. So your teacher is bad. So what is Creative Commons anyway? A public copyright license that enables the free distribution of an otherwise copyrighted work. This is used when the content creator wants to give others the right to share, use, and build upon the work they have created. And a lot of people actually do this, guys. And that's a great thing. Like maybe I took a beautiful picture of the sunset and I just love beauty. And so I decide that I'm going to use the Creative Commons license so that everybody can enjoy this beauty. And if they could make it even better, they could. And if they want to sell it, they could. Well, no, I don't want them to do that. But anyways, open source programs that are made freely available and maybe redistributed and modified. Open access, online research output free of any and all restrictions on access and free of many restrictions on use, such as copyright or license restrictions. These are really awesome, right? Really awesome things to reduce the digital divide, okay? So here's your next question. This is slide 175. Let me take you there. That was a lot of reading you had to do. Okay, let's go. Tricky question. All right, so this question is supposed to be easy. 56 of you responding. Maybe I'll wait like 10 more seconds. All right, let's go. Take a look at the answers. Most of you said A, of course. That was too easy, right? So because you already purchased it, and if you're just watching the movie with your family from your laptop, there's no problem with that. When you make a copy for your friend, nah, you should have bought another copy, right? And then when you charge your friends to watch the movie from your laptop, that's not okay. You didn't buy the movie to make money off of it, right? There's a different license that you have to purchase. When you upload your video to a peer-to-peer network, that actually happened a lot recently, right? And that's not okay. So yeah, let's move on. Safe computing. So again, a lot of reading, a lot of things to remember, right? So you already know that personally identifiable information is probably things like your social security number, age, race, phone number, medical information, financial information, and your biometric data. But then nobody remembers that PII is all of that stuff, right? It happens to me too. So just remember, PII, what does that mean? Oh, okay, personally identifiable information. And what would that be? Some stuff that would help people identify who I am, okay? All right, so search engines can record and maintain a history of searches made by users, and that's totally okay. Did you know that? Unless you said no. Websites can record and maintain a history of individuals who have viewed their pages. That's totally okay too. Did you know that? Devices, websites, and networks can collect information about a user's location. Nothing wrong about that too. All right, technology enables the collection, use, and exploitation of information about, by, and for individuals, groups, and institutions. This is all very true, right? So if you feel a little bit uncomfortable about a few things, good. All right, so then starting from here, you know what I did? There was just so much to type. So I just did a screenshot because really in Big Idea 5, the biggest thing that you really have to do is just read all these stuff, right? All this stuff. If you're getting frustrated because I just went through all of those slides and did not give you a chance to read it, okay, I'm gonna tell you this right now, okay? So if you look at the bottom of the comment section, you should have a link. And when you click on that link, you should see this, the APCSP course and exam description. I don't know if your teacher ever talked to you about this. Quite frankly, I never told my student this. So I feel like a cheating teacher, you know, like I'm cheating on my students and giving you some goodies and not giving goodies to my own students. So I feel bad. But what you're going to do is when you click on that link, right, I want you to just kind of scroll down. These are basically what your teachers are reading to make sure that you guys understand these things. You see what I mean? So basically, whatever is going to be on the AP test is going to be like all here. I know you don't have enough time to read everything. Duh, nobody does, right? But I was just thinking that big idea 4 and big idea 5, especially big idea 5, is worth reading because a lot of the questions are basically just listing the things that are here. So I'm going to tell you to go to big idea 5, which is going to be page, hold on, I'm going to tell you. So see, here's more information on parallel and distributed computing, and this is on PDF page 114, right? But that's not where I want you to go right now. Here is big idea 5 starting at page 116 on the PDF, not on this because it says page 110 in the actual CED, right? But I'm talking about the PDF page, so you can just type in a number in there and get there super fast. And so I just want you to go straight to page, what page are we on? 121. So starting from page 121, click on that link and then go into that box right there and type in 121 and then enter, and then you will see this. And you know what I'm going to have you do? I'm just going to have you read everything here. Everything here. And if you read everything and you understand everything over there, you're going to be good for the test when it comes to topic 5 because there's no coding for big idea 5. It's just you understanding a lot of things, which just happens to be common sense. Okay, so I need you to bookmark this right now and write down the page number because this is like a massive thing. You can see that it's out of 260 pages. So I need you to go to page 121, and that's where you're going to start reading. And you're not really reading anything, just where it says essential knowledge, just all these things. Make sure you understand every single sentence though. Okay, you can also look at my slides obviously, but why not go straight to the source, right? Okay, so now that I have given you that very important present that my students don't have yet, I'm going to tell them on Monday. Don't worry, they're not taking the test on Monday. So anyway, I am not really cheating on my students. I love my students, and they're going to do well. So there you go. Here's the question. I'm going to wait. All right, let me see if you guys are ready. 25 responses. All right, let's take a look at your answers. Most of you said A. Yes, good job. So when you're browsing in an anonymous window, what happens is they delete your cookies, okay? And your browsing history is no longer seen. However, it does not protect you from virus attacks, right? And you can still log into your email account and everything. It's just that it won't save the cookies. So when you try and go back to your email account, if somebody types in on the browser gmail.com, it will not go to your email account. It will go to the other user's account. All right, so the correct answer is A. The cookies are deleted. Okay, all right, so honestly guys, there are more questions, but I can't go over them with you because time's up. Okay, so I apologize, but I'm going to tell you that um, the best way for you to get anything done in terms of doing a good job with see all these questions that I'm asking you. There's only a few slides left, but all these questions I'm asking you, you can answer by just reading these things. Okay, it would tell you over here. See, it talks about the digital divide, and I basically already wrote all that information for you on the slides. Computing bias is here, crowdsourcing is all here. But see, if you look at legal and ethical concerns, all these things I already wrote in my slide. Okay, so just read through this. It's talking about Creative Commons. See, Creative Commons, open source, open access. This is our teacher's cheating guide, right? And so, yeah, I am totally over time. So I'm going to tell you that you have to look at all of this. PII information is right there, right? So I asked you questions like, what is key logging? So if you read through this, it would tell you what key logging is. It tells you what a multi-factor authentication is. So you have to read this. Before you take your test tomorrow, please promise me you're going to read this. Because when you do, and then you understand what it's saying over here, or take notes, right? What is phishing? It tells you what phishing is. This is what teachers look at, and we know we have to teach this to you, okay? So you're going straight to the source. I'm giving you something really, really special. Now, before I let you go, I just want to say, of course, tomorrow, everybody is taking the test. That's the first administration, but some of you are going to be taking the test on the 26th or June 7th. The CRAM task is due on Thursday, May 20th at 11:59 p.m. Eastern Time. Don't forget that. And if you just can't get enough and you want more resources, here's all of the links that Miss Boyd has created for you. But of course, don't forget the link that I gave you. The CED is very important. This is the teacher's Bible, I'm telling you. All right, so think fiveable. And please keep the conversation going in Discord. Thank you so much for being with us today. And yeah, if you have questions, continue to ask Miss Rachel Yun. She is an amazing TA. Thank you so much for showing up today. And the very best of luck on the test. Bye, guys.